All right, let's start. Hello and welcome to Runic. Back to Runic. Last time we did a bunch of stuff with the streaming stuff. The whenever you have yeah, I have the streaming examples here. Whenever we have like a tail, like this operation, we didn't get any output because Runic tried to wait before Runic tried to wait until the program was done and then gather all the output. Gathering all the output during the program execution and wait for it to end and then forward it to whatever it needs to be forwarded to. But now we have streaming, so now this should output the first lines of codes or whatever in server.log, and there you can see, and then it hangs because tailf hangs. So now that streaming thing works, and also it should work potentially also if we have a block now as well, because I've been working a little bit on that. So if we go to scope refactoring, I'm just having this as a test file to test all the scopes. So basically what I did was, So every time you make a block, or you have a function, or you have a for loop or an if statement or anything, or even just a binding here, we have to kind of change the context of the execution. So in the block here, we have to supply, well, we kind of have this generic block runner which can run a block in a specific context. So this will be like a new scope in here. So basically, if you if you say some kind of variable here, of course, this will only be available in here and not from outside. So you cannot do this, for example. Yeah, you get a file not found error when you don't have, when it tries to access like an identifier that does not exist and is not a variable. It's not an identifier that exists, and then it tries to execute it as a command or an executable, and then we get the file not found error. So it's not available out here, but it is available in here. So if we do this, we should get a bunch of hellos, except this code down here actually right now is broken, so I have to do this. And now you can see we got hello from here, this is that hello, and hello from here. So S is available here, and then P is echoed out here. So we have this scope. Now what I did was, first I created this kind of streaming context or forwarding context that was kind of its own thing that you would pass into the executor or whatever that would run the code. However, I realized that maybe we should actually incorporate the execution, like the forwarding context, like which pipes, basically the pipe mode of each pipe, like standard out, standard error, and just incorporate that into the scope mechanism that we already have. So now if we go to the scope here, we have a bunch of new stuff. So the frame can now be a different thing. We have 4 different kinds of frames. So basically a frame is, well, before it's kind of thought of as a container of bindings, but now it's actually more like we have this scope stack, which is a stack of things and it basically keeps like the context of the execution in check. So we have this scope stack, and each frame, each scope stack has a bunch of frames here, and so it's a stack. So the idea is that the one on the top is the one that gets priority. So if you have bindings on the top, that will like shadow bindings further down, for example. But then we also now have things like forward context. So forward context is, you know, we have standard out to standard error. So now we have information about where we should pipe these standard out, standard error, and all we need is the scope stack, because the scope stack we have been shuffling around in every call basically anyway, and it fits the purpose very well. So this was a really nice solution. Because yeah, we didn't need to change a bunch of other stuff. And so now we can have, you know, for example, where is it? We can just get, if we have a scope stack, we can just get the standard out pipe that we should forward to by using this function. So yeah. That's really, really good. And so yeah, very easy there. Now we also have, I added a scope ref frame type, which basically the idea is that we will reference another scope in one of the frames. So one frame will, so we basically take in the whole scope. So basically if you for example, want to execute a function, now we can take the closure of that function, put it over the current like context that we have, like put it over the whole current scope, and just execute the function on there, because the function needs its own closure, but we also then have, you know, the scope of things like basically we also have the scope of things around us, so the forward context will also now be part of that. So the function will know which forward context it's supposed to use. So basically, if I show you here a little bit, so let's say we have a function here, and if you call the function here, it will use the forward context that is like, you know, the forward context is standard out standard, so it will use the main process standard out standard. If you use it in like a block here, it will use whatever context is in the block. And normally now when we have a binding, we actually bind the standard out standard into P. So now this function will get run and just forward its whatever standard out standard it has into P now instead. So it won't get put, it won't go out to the outer context. It will actually stay in P, and then just like this is doing here, except we call the function. And it's also true if we do something like this, if we do just hello here. So anything in here, when you have a binding, will be like in its own context, and forward its standard out standard to this P here. So yeah, so that works. However, there's something broken with the function call, and I think what's going on is something to do with the closures, I hope. And one last thing that I want to change here in the scope is to make every frame rseed, because a closure can refer to the same scope as, you know, let's say this function here. This function has a closure which is the outside scope, the whole file, right? But it also, the whole file, the execution of the script also has this closure, or I mean this scope. So both of them share this scope. So what I'm thinking is, if I make frames rseed, then they can share the scope. I guess we could also use scope ref, but that doesn't really work in this case, because the scope can change. So if you have the scope stack can change, because it can change its frames. So, and also the frames can get initialized if you pop a stack, if you pop the stack, the frame will disappear and get deinitialized. So we want to be able to keep the frames in RCs to prevent them from being deinitialized by other scopes, so that if a function still refers, let's say you import a module, right? But the module exports some function, and then when the module has completed its execution, we basically could deinitialize that scope, because the module has its own scope. But if we have a function if we have a function that we referenced when importing the thing, we can then keep some of that context in there, whatever we need, and for the function, and then when the function goes out of scope, that gets cleaned up. So basically, the idea is here that if you have, because you can define a function anywhere. You can define a function inside another function if you want. But when this goes out of scope, this function is basically disappears. But here, yeah, and the same thing here. When this block goes out of scope. Also, this is perfectly legal here. This is shadowing this one, so this will take over, and you would run, if you run this hello function in here, you would actually run this hello function. And you can even do, well, you can't do function references right now, so anyway. But yeah, this would run this function, but at the end of the scope, this will get like deinitialized. Because these scopes get popped. And then this is part of the binding. This is a binding in this scope. So this function will get deinitialized along with the closure as well. Okay, but I think we need to make the frames RC'd, or I mean, the only thing we really need to make RC'd is this, because this is already RC'd. This doesn't really need, this is copyable, so it doesn't really need to be RC'd. It's just two pointers basically and some extra data. This one is already a reference, an RC. So this one is, I guess, the only one that needs to be RC'd here. And so, yeah, we can do RC. So now, and that's that. No, but we need to do some more stuff here. But yeah, so let's see. Init single, yeah. So basically, when you init single, this becomes like an empty one. But now we can't do that. Now we need to have a, like a allocator here. So actually, yeah, either you have like a ref that you already have, then we should have init single ref actually. Or you make a new ref, or I mean a new single new, maybe we should call it. If it's new, then we need to like init allocator empty, and we need allocator if it's a ref, we have to provide the new ref here. So yeah, we just provide the ref, and it has to be refed like as this is here. This just takes the ref and moves it in here. This should also do the same. So this just puts it there. Okay. Right, so now this is different. So now we actually need to wait, that's not the correct type. It's .ref afterwards. There we go. All right, so now we get the bindings ref here, and to get the bindings, we just say ref get. Oh. Wait, no, actually here we will do bindings. No, actually we just call bindings ref the initialize. Yeah. There we go. Now the scope ref. Yeah, the scope ref should also be deinitialized. Yeah, what am I thinking? This should also be deinitialized, of course. Because otherwise it will be a ref hanging around. Okay. And we don't need this now. Yeah. And we got a whole bunch of errors. So now you can be bindings ref, and then we get bindings equals bindings ref get. You don't need that. Alright, so now we get some errors over here. So let me also check something, because now we're passing in an array list, but I think the RC is kind of like, it's sort of trying to automatically handle deinitializing the inner values. So I'm gonna see if I can check, like what we do right now is we check if it's a slice or if it's a pointer, and when we deinitialize, we will try to deinitialize the inner value as well as best as we can. So we're calling a deinitialize function if it exists. If we have a slice, we loop through and deinitialize everything inside. We free and destroy. So we could actually wrap it in a helper that will, you know, when it's deinitialized, it will actually deinitialize it proper. A deinitializer wrapper for array lists. What I was thinking as well is that array lists probably a very, it's a very like usual pattern. So perhaps we should add some kind of detector to detect if it's an array list, and then have a special deinitialize procedure for that. So what I'm thinking is that, I mean, we have t, but you can't just say like if t is equal to array list, because it's generic, so we don't know what we should put in here. It's not really clear. We could try to look at if we have a, or yeah, if has field items, and if type of pointer items is equal, or if this, yeah, then that has to be like a slice, basically. We don't have a function that does this. We should really have like a function here instead. This is like is slice. I guess we could have like is array list. That will become a little bit easier. So we'll look at, but now we don't have items. But yo, borrow checker, how's it going? I'm calling you borrow checker now. Hope that's okay. Okay, so let's do that. It has field items. Does this break if it's not a... No, it's just a bool. I mean, it could still panic or something, but I guess we'll try to get the field here. So field info t items, and then we have like field type, and we'll do switch on that, and we'll say if this is a pointer, and if the size is the slice, we break true. Now actually, you know what? We have the field. We can just return if t t is equal to array list field, because field is the inner type. No, wait, it needs to be the inner. Okay, so actually we do need to check. Yeah, we need to extract the inner kind of type there. Is there like a element type? Yes. Returns the element type. Okay, element type is gonna be field type. Yo, blue. I think the third letter there, isn't that not, that's not I. I is just a straight line, right? No, it's N. Oh, I'm stupid. I was like, wait, there should be an I at the third letter level. I'm too tired, or it's too early in the morning. And you're using also the same runes that I did in a thing, which is cool. I was planning on using like runic alphabet in the game for like some of the graphics or something. I'm not sure, but yeah, I think so. But it's like 8-bit, so well, maybe it could be displayed as some kind of text, untranslated text. Okay, so this is a type. Yeah, so that's the element type. And if, wait, what happens if this fails? Is that a compiler error? That is a little bit annoying because I don't want it to be a compiler error. Then I would have to check if it's actually, well, I guess it's fine, because that means you're trying to put something in there with items in it that's not an array list. And we get the error. Yeah, we should get the error anyway. So we will, okay, so now we have that element, so we will just do this now. We have to do equal. So we're testing if t is equal to array list of elements. So then that means that this is an array list that you put in here. Or yeah, I need to break like this. Otherwise we will break false. Okay. What about this one? You also be compiler error. Okay. So we have to check if we have items first, and then we can just assume that it's basically an array of some sort. We check if the whole type is an array list with this element, and then we know it's an array list. So now we can use that down here in the initialize. Before we do this, we can say if we are dealing with an array list, we will just, yeah, we'll just call the initialize, because the array list has it needs an allocator, right? So we'll do that. But before that, we will go through all the items. And we will call the init if exists on the item as well. Okay. Scope stack does not support has field. Okay, okay. So I guess we'll have to switch on t type info first. And if it's a struct, we will test this. otherwise will fall through. What? Oh, there we go. No, there we don't go. Some of these errors, I don't. There seems to be some weird syntax issue somewhere. Where is that? What is going on? Actually, we could do away with the whole break here. We can just do this. False. I think you can do it like this. Found dot. What? But there's a dot here. Oh, I see. There we go. Or there we go. Yeah. Where you put the label is basically you have to get. I think you have to basically get used to it. I think it's like you can put it before a block, so you have to put it like next to the brace. I was thinking like, yeah, put it here, but yeah, obviously it didn't work. But okay, yeah, and you have to wrap because struct is a keyword, so it kind of messed up the parsing here. So you have to wrap it in like at quote double quotes. All right. Now, when we deinitialize the RC, we check if it's an array list. We have a special like deinitializer for that. We're looking on the items, and we're deinitializing them. I'm almost contemplating to do like if we don't have any like if we get a type that's not like supported on the initialize, we get like some kind of message or something. I mean, technically we could just have an RC of a literal, but I don't know. I guess if we get a literal of like, or if we get a RC of some kind of struct, then we might report like unsupported type or something, and we have to kind of implement it. But right now I'm just adding things as we go here, but we should have a better system for this. But okay. All right, so now why is this like yellow? Okay. Oh yeah, the LSP restarted. That's right. Okay, so now the singles are refed now instead, which means they can be shared between different scope stacks, which is good because we don't need to copy them, and we can keep it around as long as it's needed, which gets really tangly really fast if you have a bunch of you know, user-generated code where you don't really know where and when to. It's so much easier to just have an RC here. I'm not sure if it's even possible not to have it, but yeah. Great. Now, We do have a function that creates a closure, so I'm gonna take a look at that. Which does create its own scope stack, which does make sense, I feel. We're creating a scope stack. Maybe we should even have a ref. Actually. Well, let's do it like this for now and we'll see. Yeah, so this creates a new scope. We put some frames in there. We're basically cloning our frame or our scopes in here. So this is where I want to now say that this is a ref instead, and the ref is gonna be ref here. Now this is this is weird. It's creating a single every frame. That doesn't make sense. No. No, I'll remove that. That's weird. This basically is that because here we're trying to push a frame, but we also, this whole thing is trying to push a frame. We shouldn't push a single every loop. I think this is just, I missed this here. And this one just declares a bunch of bindings. So this one, we get the ref here. So now we can do bindings ref. Yeah. Or yeah, we need to do try. And then this one declares like closure rest, but we don't need to do that now because we already have the whole thing. All right, and then here we have a scope ref, which just creates a new ref of the scope. For context is copyable, so we just copy that. Init blocking is just an enum value, so that's nothing to worry about. All right, cool. Looks way cleaner as well. Right, so what now? We should have like a bunch of errors. For some reason I don't see any. I mean, we should have like init single at some places. Like, why is this not an error? Hello, Aditya Kubar. Yes, I'm very well, thank you. And you? Welcome. Why is the thing not working? Oops. There should be a whole bunch of errors here. Let me restart. Okay, there we go. Expected type, metafield, enum aligned. Found that. Okay. Oh, it expects a field enum. Okay, so then you have to do like dot items. Expected bool found void. You are a bool. Where is the bool not happening? Here. Maybe the else of the if. There we go. That's why I like fall through better, but so we don't have to repeat there, but whatever. And we have some of this. So now we get these errors here. Yo, Penguin, welcome. How's life going lately? It's going good. It's going good. It's a little bit... a lot with Christmas around the corner and stuff, but... thank you for asking. How are you doing? Single in a single. So this one would be what are we trying to do? Just a new, entire new thing. Yeah. So this would just be new then. And we need to pass the allocator. Actually, do we need to try this here? Oh yeah, you need options. I think this is a try, yeah. Okay, here we go. Let's deal with these ones first. So pop frame, initialize, same frame, declare. Right. So we need to get bindings. It's gonna be frame single get. Whoops, did I see? No. Which will get us the array list, but we probably need to get the pointer, to be honest. This needs to be a pointer, yeah. So let's get a pointer instead. Okay. I'm struggling for my first jog. I'm in last year of my college learning full stack, doing DSA. I'm not sure what DSA is. Deciding should I learn AI ML, very messy. I wasted time earlier, so I have to struggle now. Well, yeah, that's tough. I mean, I think AI could help some, you know, if you have like specific, if you want to get an answer to a question real fast, and you don't find the answer on Google, you can use AI to get answer to the question. Like if you're trying to study something. Or what did you plan to use it for? But then you have to keep in mind also that it could be it could also be wrong, so that's also like the risk there. But it has been quite good recently, so but there's still a risk that the AI just makes stuff up. Data structure algorithm. Oh, okay. Oh, for your first job, maybe you meant to type. Oh, or are you gonna go out and running? Yeah, I don't know, man. Is there a way to like redo? You're saying should you learn machine learning? Like, do you mean creating? Yeah, job, right? Do you mean creating AI, or what do you mean? I'm assuming learning like using AI, because that I think you should learn that anyway, because I think it could be a nice tool to have. But it's also very important to, of course, learn, you know, programming yourself, so you can be sure that things are actually correct. Because AI is not that good. It's not that good to just fix all your problems for you. Oh, creating AI. Okay, well that's yeah. I'm not too familiar with that area. It's probably a deep rabbit hole, as far as I understand. So I can't help you there. But I mean, it is probably, I don't know. I haven't researched it, but you could research like how many job opportunities it is for that kind of thing. There are a lot more applications for AI than generative, like in recognition tasks. Okay. Oh, applications, like usages. All the best with joining the stream, man. Oh, okay, okay. Have a good one. What's going on here? So this is, yeah, we just need to, this is the ref, so we need to get the bindings out. Let's get the pointer. And yeah, that should be it. Okay, now I'm thinking about the initialize of the scope. Where's that? Here. So we're initializing each frame. Yeah, that should be enough. And then each one, this is just initializing the ref, which should take care of the rest as well. So that should be, we don't need to go in and, you know, loop through all the bindings and initialize them by itself, because RC will automatically do that now. Very cool. Right, so now we have a bunch of these we need to fix. Now this one should be just a new ref, I think, or a new one. So this is new. I think basically all of these are new. Oh, they also need to be tried as well. Okay, that's it. Let's see if it succeeds now. So let's go to our scope refactoring. Now before this, I think this created like a so yeah, a leak. So this is scope refactoring. So if we run this now, oh, we still get leaks. Okay, we still get leaks. So let's enable executor. Now we can see here that Yeah, we actually just declare this binding, and then we don't do anything else. So we create a closure. You can see here. This one pushes 3 frames. It copies the frames from outside, basically, or not copies, but it like references the frames outside. Which allocator are you using? Yes, the general purpose. Just so I can see all the leaks while developing here. And then something pops from the outer scope. Right. I could put the tag name of the frame type as well. Actually, whenever we push a frame, we could put the tag name of the frame. Well, this one would just be tag is tag of frame equals forward context, and we get tag name of that. Yeah, we could also take this value here, but yeah, whatever. No, tag. All right, now we should see what kind of frame we are pushing here. So here we have a forward context, here we have a single. We're pushing execute, also pushes a forward context. So this one it just takes all of these and puts them in here. And then we pop one of these, a forward context, from the outer scope, and we deinitialize the scope, which should deinitialize the function, and for some reason the function does not deinitialize the closure. So let's look at that. Well, I don't understand, like the LSP, just sometimes it just gives up. Like I can't go to definition now. Oh well. This one deinitializes closure. However, are we deinitializing this value? I mean, it should be able to deinitialize this. Yeah, the closure, the scope. What is that? Do we need that anymore? Function ref. How does this work? So we push a blocking frame, so we don't we're basically blocking everything like outside of the closure, so we don't like accidentally overwrite, something outside of the closure, or something out like in our context where you actually call the function. It shouldn't be able to like grab whatever variables are in that context and do stuff with it. Or like, for example, if you call a function, it shouldn't be able to grab functions from the outside scope. It should just have its own closure available to it. And that's what this blocking thing is doing. So it's blocking the rest of like the things. And then we have another frame here, which is the scope ref. So this is the closure. So this is how we get the closure into the context of the function call. And then we have a frame forwarding here as well. So we're forwarding to these riders here, which are, these are like blocking riders, I guess you could say. Which is not really how we want this to be, I think. I think we need to change that actually, but anyway, that's how it is right now. So anyway, so we do this, and then we push a new single frame there. We run. Wait, we don't actually do anything. Okay. Well, this is when you run the function. Okay, so this, I didn't actually implement this before, because what we did before was basically we tried to use like the executor to do stuff, but now we don't really need that anymore because of the refactoring to scopes. Scopes is like super powerful now, so we can just skip all that and we can go through ref declaration body, and the body could be two different things, so we have to switch on that. And if we have a block, we get a block out, and we can loop through statements, and then we just do run statement, scopes statement. Well, we don't need it to be a pointer anyway. And then we get some kind of maybe value out. If we don't get a value, we can just continue. If we get a value, we need to deinitialize it because we basically throw it away right now. Okay, so then that's it, I think. We need to try here. There we go. And then we also can have like an expression function where this would just be yeah, we just execute the expression, I guess. Or technically we should evaluate it and then throw away the value. So we get a, actually this needs to be bar as well. So we do like self evaluate expression and then deinitialize the value. All right. Oh, you need what? Allocator. Okay, so now we actually run the function. Like, I'm not sure what happened before, but now, okay. Let's also look at this. But we don't actually run the function here. So there's something weird going on. We just declare a function and then it doesn't clean up properly after itself. So why is that happening? Let's look at, well, it's a value. So we have like interpret a value. So it's a function ref, and it deinitializes the closure. But apparently that doesn't do anything. Because if we look at the logs here, this deinitializes the scope stack, and then we show everything that it deinitializes. It deinitializes frame 0, and then it goes through frame 1, and all the bindings here. So all the bindings here should be deinitialized, but they are not. Maybe it's because of the RC change. That could be the issue. Like maybe this fails here. If it's an array list, we go through each item and we call deinitialize on it if it exists. So that should propagate through. And then we also deinitialize the thing. So for some reason, because if we called deinitialize on the closure, we would get logs for that. It should have shown here, like after here, but nothing's shown. It's just a bunch of leaks. So what is going on? Do we ever get in here? I would just say let's log dinit and we will deinitialize array list. Here we don't. Yeah, here we actually we can deinitialize a. This is just a random struct that has deinitialize on it. And this is a slice. And then this is pointer 1. All right. We could I guess we could also show like the type. But I think we get the type from here, perhaps. We'll see. Error union. Oh. Wait, why aren't these? Is this never called or something? What? Self? Oh, it's a catch. I see, it's a catch. So, oh yeah, that's the whole point. So we don't have to have the initialize. Right. Now it's getting back to me. We don't want to have a error type in the initialize because it's so annoying when you have to defer and you can't try, so you have to like defer and then catch and whatever you want to do there. So it's nice if we don't have to do, if we catch the error here instead, whatever error it could be. Just generally not having to have errors in the initialize functions. Okay. Are we good now? Yes. But we're still doing this, but yeah. Oh yeah, we need to enable logging for RC. Oh, and now we get a bunch of errors here. Oh, I see. Let's just catch them here. So we should get logs here. Here we get RC. And here you can see the whole type here, so we don't need to put that in there. But that gets released, and then there's one ref left. Interesting. So let's look at this address here and see what's happening. Where is it initialized? Over here. So we initialize it here, and here we get a new ref. Right, so now we have two refs. And this one is new. I forgot what that meant. Now, I thought, hey, these labels should be helpful, but I forgot. Oh, I see. This is basically just saying, all right, so it's basically saying we're creating a ref from another ref, and this is the source, and this is the new one, right? So this is the source ref, which, yeah, it's ID 0, that's the source ref, and then ID 1 is the new ref, right? I should probably put like ID here, so it gets super clear. Yeah, ID. And then this is like the label. I don't think we need to put anything there. Errors in the unit makes it cumbersome to defer, right? Like you can't try them, you need to catch and handle. Or MMP9. Yes, that is true. Oh, you're not a developer? Well, you have a very good understanding. I thought you, for sure, you were a developer because of your questions. So, yeah, so now we can see, like, we create a new ref here, it's ID 0, we create a new ref here, however, it's the source is ID 0, and the new one is ID 1. We should probably, I want to have this in the same line, but I don't have a good utility for that. So, and then we just release one of them, so ID 1 never gets released. And that's probably the closure here. Yeah, we're pushing a closure frame, then the RC gets created, and the closure never gets deinitialized. So yeah, that makes sense. And that's why, wait, but the closure should get deinitialized here. So it still doesn't. So this scope stack deinitializes every frame. Hang on. Scope. Yeah, so basically, okay, if I just explain there, sorry, I'm not sure if I answered your question there, the incredible laser. Yeah, so basically, if you, when you try, it basically, it changes the return value of the function, or it can change the value, because basically what's happening is you, instead of try something that fails or something like that, let's say, what it's actually doing is that this is equal to run this, but then catch the error and then return the error. So in the case we have an error, we return it, but otherwise we continue running. But the problem is that we have a return statement here, and if in a defer you can't actually return anything. You can't return from a defer function, so you can't have a try expression in a defer thing. So that's why it's super annoying when you have something that's like the init, because you can't try it. So you have to do like this, but that just feels super bad. And you don't want to sprinkle this all around, so because you want to catch the actual error and do something with it. But then it's better if the dinit actually takes care of that itself, because deinitializing shouldn't be an issue normally. So yeah. But I had like errors there because it's because I tried to log something and that could potentially fail. So we do that. What am I doing here? So let's see. Oh yeah, also we do a detach. That's right. Wait, when do we do a detach? This is a new function that I made that will... Oh, that's on import. Right, we don't really... I have to try this as well. The import. But before I used like a whole new executor for the imports. And then I had to modify the documents to have like each document had its own executor. But we don't really need that now. We can just use the scope to push a blocking frame, and then we push a normal frame in there, and then we just run the module. And then I made this detach function which will take the recent most couple of scopes and detach them into a new scope that we can then just return. So this will pops these two frames and puts them in a new scope and returns that. So we have to try this as well. But basically, yeah, the scope refactoring was really amazing because it just eliminated this whole mess with all the different executors and stuff, and just a whole mess really that we have. This is a much nicer execution context thing. It makes sense when one thinks about it like that. Defer basically means run this last statement before return, and if it contains a return, it will need to run before itself. And try implies return. Yeah, basically. I mean, I guess technically there's like you could probably change the return value at the last minute, but I think they don't allow it because it probably becomes too confusing or something like that. So I think it's probably technically possible, you know, if you have, but then it's like, okay, if a return, okay, but then it's like if a return happens in the defer, if you have several defers, defer 1, defer 2, defer 3, let's say, now they happen in reverse order, so defer 3 will happen first, then defer 2, and then defer 1. Which is a bit confusing here, but what's gonna happen then if this one returns a new value all of a sudden, and even further if you have like an defer, is that also gonna be called now if this returns an error all of a sudden? This is called, do we call the other defers again when this returns? Like, yeah, that becomes a whole mess, I think. So that's, you know, you could decide to maybe make it super simple and just say, well, we just change the return value and that's it, or something like that. We don't run the defers again. But I think that becomes too confusing or something. Maybe it's not even possible. I don't know. Okay. Where are we? Oh, this one actually we need to deinitialize as well. if we got it, if we get a value, we will deinitialize. All right. Well, we're not doing this right now. We're trying to fix the issue. Yeah, I think the problem is still that this doesn't release. I wish we got RC here. Maybe it's because this doesn't get. Maybe it's because this doesn't ever get like deinitialized, so this never gets deinitialized either. Because the the reference in here references this. So that's maybe why we don't get this initialized here. Like this function has a closure that references this one, but when we release the original, we still have the closure in here. Okay. Right. Yeah, so then that means that when this releases, it never actually deinitializes the inside because we still have a reference to it somewhere. I'm thinking maybe we should make this into an RC as well. Wait, how would that solve the issue though? True, though I don't think the current design is bad on its change. No, I don't think so. It's just you have to kind of work around it. It could be like a bad pattern anyway that you're trying to do, so I like it the way it is. You have to sort of conform to the thing, which is good, I think. It also makes sense that tearing something down shouldn't like generate errors usually, so it's good that we have this thing. Except for like memory leaks, that is good that we get errors here. Although, yeah, you usually have this at the end of the program. So, by the way, do you have something like a design document or something for the language you go for? I mean, okay. So let me explain a little bit about this project. So I do have a GitHub that is in the description, but the foundation is AI generated, and so after a while the AI just messed things up a whole bunch, so I had to so I just took over now, so I'm doing everything manually. Basically I'm using AI very sparingly now, just for like super annoying bugs that I don't think that I can fix quickly, or that it would take too long basically to investigate. So I can tell AI, hey, could you investigate this and get some kind of suggestion to what to do. But otherwise, I'm not really using AI anymore for this. I think it's too complex now for AI to deal with. Because yeah, I don't know. I could probably bring it back at some point, but I need to align the whole project to the direction that I want. The AI basically went in its own direction, and it kind of spawned all these different branches in the project that just didn't really work together that well, and then it just failed to do work. So I just took over, and it's been really fun to actually to do this. So so now I'm making it the way I want, and it works a lot better. And but anyway, the point is that the documentation, basically all documentation in the repo is AI generated. So, and it's also like AI generated from this, like I haven't updated it, so it's basically been there from the start. but it gives you kind of an idea of what it is. So, and I can also like give you a little bit of a rundown. So basically it's going to be like a bash-like scripting language that it kind of works like bash. Like you like this executes the executable echo, and you get like standard out, standard error pipes and stuff. You can pipe things, just like bash, and so that's the idea. It's kind of like a replacement for bash script basically, but it's also it's really just a toy language. It's not really I guess meant for people to actually use. It could get there, but right now it's just a toy language though. But I just think it's fun to learn and implement my own language. So, and it's also for me personally, so I can basically, because I don't want to deal with I don't want to learn the bash syntax. so I make my own language with Zig syntax that I like and that I can reason with, so that I can actually build the bash scripts that I want to have. So that's the whole rundown there. But yeah, the repo is available, and the return type is really not. You can ignore this for now. Like this is not the final thing. Like what I'm going for is something like a typed pipe. So you could take a string in or a void to say that, hey, this shouldn't receive any standard in, let's say. So I'm thinking of this syntax here. If we have a standard in and then a standard out. However, you can clearly see that this actually, like you have standard out here, which is a string. So this would be this type. Otherwise, it would be like a type error. So this one has like standard out string, void, and then you could potentially add like parameters here as well, just like normal bash functions, except you put them in the actual parentheses and not like as statements inside. So this is the idea. And then you would potentially you would have something like you take a string, you have a parse int function, for example, which produces an int, and then I'm not sure exactly how this is gonna work, but let's say we have like a special thing called standard in, and then we we can capture that in a variable, for example, or we could just use the symbol as is. But basically we would do some magic with the standard in to parse it into an int. It could also be an error, so we can have an error type as well, so parse int error, just like in Zig. And so then you would have typed errors as well. So not only like exit code is no longer just an integer or a byte, it's an actual like error as well. Like in the Runic world, this is how it would work. And then you do something with that. And now we can use parse int in a pipeline. So basically you can say echo 5 and we parse int. And at this point, the int, we take this from standard int and we produce an integer or an error, but we produce an integer. So now we can pass this into a function that takes int as, as in standard int. So that's kind of this is the idea. So basically that you would have like typed pipes, but we're kind of a long way away from that right now. But it's just an idea that I want to explore a little bit. And then also like Runic files themselves act as both like modules, but also as functions themselves. So what I'm thinking is that if you just want to run a Runic module, you can use import and you would do like something runnable.rn or something like that. So you would be able to run it like this, but then you can also you can also set this to be lib. So now we bind the import to this thing here. So you can actually use the functions on it, like doing that. So yeah, but doing this wouldn't give you access to the functions. Doing this would just run the file itself. You have to, if you want access to the actual scope in here, you have to assign it to a variable, and then you can call whatever library variables you have or something like that. Yeah. So that's a little bit of a rundown on what's like how I want to plan, or what the end goal is, basically, a little bit for the functions and the modules there. Yeah. Let's see. Let's try and fix this issue now. So, but this is not a valid. So yeah, I haven't updated the parser to actually like parse like this, but yeah. And then the exit code is also like implied. So basically, if you now, let's say we run hello like this will run hello and put the result here. But what is the result? So the result is a process handle, and it includes, like, you can access p.standardout or standarder or the like exit code as well, except that's not like implemented right now, so you would get like an error there. Oops, this is p, not o. So you basically you assign this to a variable, you get all the things. However, you can also just use p directly, but this will coerce. Basically, it will convert in a string interpolation like this. It will convert p to standard out, so it's implicitly standard out, just because that's probably like a very usual thing that we want. So just doing this will grab standard out and put it into echo, but you can also grab other stuff on it as well. You're always in for new shells. Okay, cool. I'm not sure if this is going to be a shell. Right now I'm just using it to run scripts, basically. Last one I tried was more Elvish. Also interesting, but written in Go. Or Elvish. Okay, I haven't heard of that, actually. Also, another thing I should say is, like, I knew that there's probably languages that are like Bash but do it better, maybe, you know, more modern syntax and everything, but I didn't really want to look anything up to taint my idea of what I wanted to do, and I also knew that I wanted to do this, so I don't know anything about Bash, new Bash-like languages. I just try to make my own thing here. Yeah, this is run on assignment, and then all the result, like standard out and everything, is put into P. It's not actually output to the outermost scope, like to the actual process standard out. It's put in this process handle, like in memory. But if you execute it like this, it will be forwarded to the outer scope, basically. So the result here would be that we actually echo this to standard out. All right, but for now we have an issue here where this leaks, and I need to understand how we should fix this. Like, really, when this is deinitialized, it should actually go in and deinitialize the frame itself. No, but it shouldn't actually, because we need a closure. How would we get to these loose counters? Do we have like a scope that's like the main scope, like the outer scope, which will force everything to deinitialize? Maybe. Because when the closure deinitializes, that's also a scope ref or a scope stack. So that should just not, that shouldn't like force deinitialize everything. This should, however, this one is like the outermost scope when we run the script. That should just force everything to deinitialize. Yeah, I think. We'll see if we run into issues with that and try to, because I can't think of a solution right now that's different from that. Yeah. So let's go to scope, and I guess we'll add like a bool here or something. We can remove this now. Okay, and then yeah, I guess we'll have like is main false. Allocator is main I guess it's better to not have a default here, so we have to say it. If we for some reason anywhere else actually initializes without the init. Okay, this should be main. Actually, let's make a main or scope type, I guess. Main main or child, I guess. It's nice when you have a bool and it's like it's more descriptive of what it actually means, and then you can see it straight in the code as well. Let's also change this to scope type. And then you are main. Okay. Detach is not main. This is a child. Closure is also a child. Cool. So we only the idea is we only have one main in the entire execution context, and then we have a bunch of childs. When the childs get released or deinitialized, they just release their refs. When the main gets deinitialized, it forces everything to deinitialize. So let's go to deinit for scope stack. And here we just do deinitialize on frame, but that's not enough now. If we are the main stack, we should force deinitialize on everything. So let's do this and then switch. Yeah, whatever. Switch on scope type. Main, we should do like force deinit or deinit force. And if we're child, we just do a deinit. Okay, now we need to implement the int force. Well, I think is main is the best name for given name or type, but that's anything. Main or child. Yeah. You are correct. It's like I've come to terms with that. Like whenever I have like a flag like that, like a bool or something, it's much more nicer to have an enum, because it gives, like, especially if you have a function that you just you have to put in a bool, and you're like, okay, well, what does this bool mean? It's just much more descriptive, and also in Zig you get this nice, you know, you can just do dot main, so you can it's almost like it's so nice and easy to read. Instead of having true here, you're like, okay, what does true mean? And I have to go in here and check, okay, it's a scope type or whatever, you know, is main or whatever. But now we say dot main, it's super clear. We don't even have to go in here and check what that means. So that's super nice pattern there. Okay, let's see if we can actually implement this force thing. Force. So the scope refs and the bindings. So let's go into the bindings. Now the idea, I guess, would be, should we like look into the bindings? We should, I mean, we could call, like, we could get the RC and deinitialize it straight up like this. Which would force it to deinitialize like the whole thing. And here we can also say force. No, wait. I guess we can make a copy maybe. Or let's call this deinit main or deinit. Let's do deinit main and deinit child. So child will just call deinit. Main we'll do this. This one will switch. I guess we can log as well, but this one will switch on self scope type. If it's main, we do deinit main. If it's child, we do deinit child. And let's call this deinit main as well. So now here we can say deinit main instead. And you would be, yeah, you could just be deinit, that's fine. But here we're forcing the main behavior of deinit here. Actually, yeah, this is the ref, so actually we would need to let's get the scope. And we should have it, otherwise we have, yeah, this is gonna be like unreachable. Or yeah, panic shouldn't happen. We will dinit main on the scope, and then we'll do scope ref dinit as well. The only thing here is like we probably get like double releases. I wish I could just properly deinitialize from inside out. This is Zig, me machine, me machina. Sorry, machina. How do you pronounce it? Right, true and function call without further description is quite useless without context. Yeah. Yeah, we just deinitialize the whole RC, which will kind of, it will force the initialization on all the, well, on the source, and basically at this point all the refs will become invalid. So yeah, and when we release them, let's say, then we get this log here, release already called, but it's just a warning and it's just a log, so it's fine. We can catch those and we can see if we can work out some idea. I just want this to actually work now. So this releases all the frames very nicely there. This goes through the scope ref and also releases that forcefully, and the ref itself, and these are, doesn't matter. And this one is not more public. That is true. I do want to force a cleanup on the whole RC though. Yeah, let's just make this public. I don't like it when you can't access the functions when you need to. Let's just make it public. The idea was that you wouldn't call this, but you would let like the refs take care of the deinitialization. But now we actually want to call this because we want to force it. Well, there might be another way to do it, but let's just try this first. Okay, so now if we're main, we should deinitialize main and force everything to deinitialize. And okay. Well, we get some weird pointers here or something, but we don't get leaks. Okay, cool. But yeah, this we need to look into. So we have so we're deinitializing main here. Why are we deinitializing main here and then we still do things afterwards? Oh, deinit child afterwards, right? Okay, so we should probably do it from inside out then. That makes more sense. So then we don't need, I don't think we need to force deinitialize these things in that case. So let's figure out how we can do that. We should still call deinitialize main here. Here. I think this is where we have to do more stuff. We need to go in and check on the bindings ref to actually walk through all the scopes that we have in here and deinitialize them as well. However, yeah, okay, let's just try it. Bindings is bindings ref get catch panic, and then at the end, instead of do this, we would do like deinitialize here. So we'll go through each of these. Actually, we don't really need to go inside out, but we just need to go, we need to visit everything and make sure that all the bindings are, all the scopes that are referenced will be deinitialized. So we'll go through each binding and we want to get the value. Let's get the pointer or the value. Yeah, let's get the value. Okay, and then now we need to basically be able to iterate through. We kind of need to iterate through like the scopes of the value. So maybe we should do like a scope iterator here. Somehow. Let's just figure this out. This will return a nullable scope stack. And we could do this, or we could also just switch here. Switch on all values. Yeah, we can just do switch. Let's forget about it. It would be nice to have one, but I think it's gonna just take more time. Let's just copy all this. Because most of these don't have a scope. I do like to explicitly go through each one. Range is, no, range does not. Array could have scopes. Functions has scopes. Process handles, I don't think has scopes. Okay, so all of these will be nothing. Arrays, we would have to like loop through and this is the thing. Now we're looping through the array, we get like a bunch of values that we need to like extract the scope again. So this function, this should really be in its own function. Gotta leave. Thanks for looking. Quick off-topic question: which Linux distribution are you using? Just Ubuntu for Windows, basically. Like I'm using WSL, so I'm using Windows with Ubuntu. Ubuntu. Not sure how to pronounce it. No problem. Have a good one. Yeah, so let's put this in its own function, which would be like init value scopes. So we can recursively call it. Function ref. And the scope. This is a ref. So the array would be get loop through the array, get the element. Yeah, see you later. Thanks for joining. And then we will call this again on the element. And then the value itself, no, the value itself should get initialized with the scope initializing. So we don't need to do it here. Yeah. The function ref has scope and closure. So we basically, I guess we release both of them. I'm not sure if we actually need this scope anymore. I'm not sure why we have this. I don't remember. There was something about the execution, like the closure we needed. The scope was, I think it was like supposed to be the scope in which it was going to be executed in. So that's just, I don't think we actually need to do anything with that. I think we just remove that later. But this one, we want to deinitialize main here. Because that's what we're doing here. Deinit main, and yeah, I'll just keep main here so that we don't get confused. And there we go. So now the function ref should be taken care of. This scope is a scope ref, I think, or this is, wait, that's a value. Like, so this would be like a module that we could be keeping around. This would also automatically be deinitialized. However, it's not going to get deinitialized with deinit main though. So I would actually call deinit main on the scope actually. And then also, that maybe this becomes a problem later, because we're gonna iterate through all the bindings later and then deinitialize them as well. So if you deinitialize this twice, that's not gonna be great. And this also gets deinitialized. However, it's not getting deinitialized with main. So in the case of functions or scopes, I actually think we need to remove them as declarations from this scope as well. So what I will do is I will add the single frame for from whence they came. So this would be frame single. And if we get to a function, we can just handle the deinitialization here. This initializes that. Let's actually do deinit main here as well. Let's have a deinit main function here as well. So then you will call deinit main and then destroy the closure. So that ticks all those boxes there. So now we can actually just call function ref deinit main instead. So that takes care of the value. Very good. And now we just need to remove this declare from the bindings. However, this is called from within here. Which, if we start to remove things in here, I'm not sure what's going to happen in the iteration here. Iteration process. So, I think maybe what we do is we have bindings to remove, or yeah, bindings to remove. It's gonna be an array list of indexes, which we will initialize in the end. Don't we have allocator? Okay, so now we need allocator, I guess. But that's fine, I think, because we could just forward it. Yeah, there we go. So we need to keep track of all the bindings that we remove, and then at the end we will just go through all the bindings to remove, just so that we don't double deinitialize them. And here we have like the index items. So now we get the index here, and we will say bindings. Ooh, actually, I want to go. I want to reverse this. Can you do reverse? You can reverse. There's even an iterator. But this does it like in place. So that's cool. Let's just do a reverse. Items. Yeah, that just reverses it. Cool. And then we go through them. So that, because then we go from the end to the start. And then we can do a swap remove. And we don't need to worry about indexes in the being... Actually, I don't think we need to remove or reverse. No, yeah, no, we have to, because the ending could, like, because the swap remove will take the index that you want to remove and then swap it with the last element, because the length of the slice will shrink by 1. So we have to fill the space with something. So we take the last element, because that's the most like efficient, and just copy it into where we removed the index there. But if we're gonna remove a bunch of stuff, then actually, is there like a swap remove many? No. Oh, there's order remove many. Okay, well, let's just do this. So basically we remove from the end, which makes sure that we don't mess up indexes that we get there. So that should be good. Now, this one should return like a bool to denote that we need to remove this value. So if this was true, then we will need to keep track of the index here. If this is true, we will and here you can also do like an enum, so you can say like if this is remove binding, which makes it a lot more clear on what's going on. And yeah, and then we just append this binding to remove, append allocator and I, and then we catch panic out of memory. Yeah, you could also init capacity to the number of items here, so we just have to do this once, but whatever. Okay, now what are we doing? So this should need to return some kind of result here. So this would be like the init main value scopes result is an enum, which is like remove binding or none. Success, I guess. No, how language, but still require OSP to look up method function to fit what we need. Thought I was alone. I mean, yeah, I think LSP is like a super nice tool. I really like LSPs. I mean, it just goes so much faster to do stuff. If it works, I would say that. If the LSP works well, I just think it's so much more productive. And you know, you have to get, if you don't have an LSP, you have to get into the mode of another mode. So it's not really a huge issue. It's just that you have to do things a little bit differently. Like right now, I don't really need to go and look up every little thing in, you know, the language all the time because I don't have an LSP. I don't have to have the docs constantly open, you know. But you know, that's not a huge issue either. But I don't know. To me, I just feel like I'm much more productive when I can just use the LSP. All right. However, this becomes a weird thing now. Maybe we shouldn't do. I mean, maybe we just initialize the bindings here, to be honest. Then we don't need this whole thing. Yeah, we initialize them and then we just empty the bindings at the end. Yeah, that's way more simple. We don't really need to keep them around or anything. So yeah, let's just forget about all this crap. And then yeah, we don't need to have this if here, we just do this. And then we get the value. This takes care of the initializing the value, so we don't need to do anything there. And then the bindings, we just clear it. We're clearing retaining capacity. But then the ref gets initialized, so the inner thing should get initialized whenever all the refs are cleaned up. There we go. But this means that the bindings no longer has items in it. So when it gets initialized later, we don't actually clear all the bindings there. All right. So Now we need to fill this in here. So so this just recursively calls this on array, so that's good. And then at the end, we will also do like no array ref deinitialize. You probably need. Let's see. Yeah, now we shouldn't. Now we don't need to worry about this either. We deinitialize the function. Here we deinitialize. So basically, this is deinitializing the value. So yes, good. Unused parameter. Oh, now we don't need this. Okay, cool. Great. There we go. What else do we have? Unused capture. Yes, great. You're not used either. Okay. Cool. Yeah, that's right. I was thinking about using that to remove the bindings, but turns out we don't need that. Expected type. Okay. You need to be get pointer then. There we go. Member function. Okay. No, so we do need allocator. Oh. Allocator. Do you need allocator? No, you don't, because you have your own allocator. Okay, now you need to also pass in allocator here. And you need allocator there. And now we need allocator here. And you can say self-allocator. And that should be it, I think. Yes. Okay. So, let's hope we take care of all the leaks and we don't get some weird double free or anything like that. Yeah. Okay. We get some issues. Oh, it wasn't that much. Panic on corrupt value. Or I mean switch on corrupt value. So what are we doing? Yeah, okay, so we can see here that we're deinitializing, and which triggers the deinitialize main because we're deinitializing on a main stack. We should probably have this here as well. Scope stack. Let's do like this. Scope type. Now we can see that this is the main scope here. And here we're deinitializing a child scope. So we're deinitializing this. And then we try to deinitialize on the child. It fails. Okay. I think it might be trying to deinitialize this hello here again. And that's why we want it to be an RC, because the RC will... well, actually... No, okay, this is why we want it to be inside out, because then when this gets deinitialized, it will also get removed from the frame. And so when we get out here to try and deinitialize, this will not deinitialize... Wait. Okay, my brain just melted a little bit.
So the thing is like this frame and this frame is the same frame. It's like the same, like it's an RC, so the source is the same. So if you remove a declaration here, it gets removed here as well because it's the same. It's a reference to the same thing. So when we then go here and say, hey, we want to deinitialize you, this should only deinitialize the reference. Oh man, this is let's see, this is a brain twister for me here. Okay, let's look at the error. Why do we get a corrupt value here? I mean, it probably has something to do with, we're trying to switch, let's see, 128. Where's the switch? It's on the frame. So perhaps we are trying to deinitialize on something that's already gone. Right, because when we deinitialize the frame, the single, we get all this, we do this, we get this. Wait, no, this is log bindings. Here. Although this is the initialize main. Yeah. So we're here. So this gets the bindings. We go through all the bindings. We deinitialize them recursively. And then we clear our bindings and we deinitialize the bindings ref. So that should initialize the single frame there. And then, so that, let's see, that should initialize this frame here, but it doesn't, like, it releases a ref, but we still have one ref left. So it doesn't like deinitialize the whole thing. But here it does, because this is the only frame left. I think what's going on is it's trying to go into the function again. Maybe we could remove the closure from the function once it's like deinitialized or something like that. We could make it into an optional. We could also make it into a ref, I guess. We could make it into a ref. Perhaps, instead. That might solve the issue, actually. Does that mean that each function ref should have its own ref? Probably. Let's just make this, actually, let's just make this into an optional. If we don't have closure, we return. Well, okay. Closure is equal to self closure or else return. Self closure is null. Oh, now this needs to be mutable. Okay. Fine. Command type. God damn it. Args. Why do you complain? Oh, because you don't need that. Oh, let's just do that. Fine. All right. Wait. All right. I guess we force this closure here. Whatever. Yeah, we're gonna notice what the issue is if it fails anyway, so that shouldn't happen. Okay. I just need to see what I did here. So basically the idea was now that the function ref doesn't deinitialize the closure again if it's already initialized. So it's kind of like a reference now, although it's like only one. But we just need to make sure we don't copy the function ref. That could still happen, I guess, maybe. Well, maybe not. We'll see. Okay. We still get the same issue. Init main. Let's do this. Let's log whenever we get here. We're gonna log Now let's actually move this to the scope instead. But we don't have access to the scope here. I guess we'll put it here. Okay, now we can say, for example, self log, and this would be like, let's do source function main and function, and here we'll have like a scope. So now we know that where we're coming from and what type of thing we are currently dealing with. Oh, we're never deinitializing these values, which we should. Except, yeah, okay, the only one that's actually feasible to deinitialize is this. Oh, also the string, I guess. Fine. But that's not really the issue right now, though. Scope. Called like inner scope, I mean. Right. Init main. Ah, wrong order. And we'll just catch. I guess we can non-scope value. Actually, we have the tag name. Yeah, we could just do this. S tag name or value. All right. Do we get some more information here? So here we can see that we're grabbing the function. I mean, we could put more information there as well, but we only have one function right now. So we're trying to deinitialize this function, which calls deinitialize main on the child scope, which again calls deinitialize on the function main again here. Right, so in the process of trying to deinitialize the child, it goes in here again. So okay, let's actually, okay, I think I know what the issue is. When we try to do this here, we're setting null to, we're setting closure to null here. But when we call deinitialize, or deinitialize main in this case, it tries to go in again here and run the closure. So I think what we need to do is we need to set closure to null here before we call deinitialize, because then it will go in here again and see that, oh, it's null, so we don't do anything. Also, we don't need to destroy it. Yeah, but then we abort if it's not set here. Okay, yeah. Okay, we still get, okay, now we get leaks instead. That's a lot better. Okay. So we're deinitializing that, initializing main. Now we're deinitializing the function, which does not, well, it tries to deinitialize function again since it's part of the scope here, but this is already taken care of, so good. And now we're releasing a bunch of refs here. There we go. That one deinitialized. We're deinitializing an array list, but we still get leaks. a declare function declaration. Okay, so one of the declares are still not taken care of. Hang on. Oh, wait. It's this. Okay, so the binding. Okay. We never deinitialize the bindings. Okay, okay. So let's see. Where is the thing? It's over here. When we deinitialize these here, we should actually now, because we have a binding, this also needs to be deinitialized. Which does deinitialize the inner part, which is not great, because we're already deinitializing the value here. We just want to deinitialize the name, really. Okay, I need to refill my coffee. I'll be right back. Yo, 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 blue. I hope you're not feeling blue. These main value scoops. Right, how do we deal with this? We could get the name, I guess, and just initialize it. But that just feels so fragmented here. Actually, yeah, we could just get the binding value, but we also want to deinitialize this ref. Huh. Because I was thinking first that it would be enough to just deinitialize everything from inside out. So perhaps this is where we would clean up the value and not in here, actually. So we don't deinitialize here, because that will happen inside. And we don't initialize this, and we don't initialize. Well, we do want to deinitialize main, though. God damn it. Do we need another deinitialize on the binding then? We need a deinitialize main on the binding. You're feeling blue? No. Sorry to hear that. Initialize. Let's see, initialize. That should just be initialized there. This one, what is the actual like difference? To be honest, I guess it's to call the initialize main actually on the value itself. Because if we're a what, we don't have a handler for scope here. Okay. Let's copy this. You have main. And you have main. You don't have main, but you should have main. No, wait, that's the ref. Okay. Then we do this. We go to the init main value scopes. And we have to basically do this here. Oops. Maybe I had a smile face comment for no reason there. Where? Here? I have a smiley face in every panic. Shouldn't happen. There you go. Little helmet. You have to like tilt your head and squint. Or maybe like this. Christmas. You heard Zig has 3 different types of comments. What's the difference? 3 different? What? I only used this one. I didn't know it had 3 different types of comments. Actually. Like, I don't even know if there's a block style, to be honest. I mean, okay, there's the normal comments, then you have doc comments, which is just, you know, it's this one where you have 3 slashes, but this is very common, you know, it's just a normal comment, except you have 3 slashes, and then whatever message you have in here is put into, like, you know, documentation helpers when you look at a function. So you can see, so you get like explaining what the function is doing, basically. Hello, Polaris. Have a nice day yourself. What else? Oh, we have top level doc comment as well. Interesting. Doc comments are only allowed in certain places. Is compilers have a doc comment in an unexpected place, such as in the middle of an expression or just before a non-doc comment? No, okay, maybe that was... Okay, so top level doc comments is one that begins 2 slashes and an exclamation point. / bang. It documents the current module. It is a compiler error if the top level doc comment is not placed at the start of a container before an expressions. Okay, so you have to have the top level would be here then. So like this. Value. represents a value in Runic runtime. So this documents the whole well, I guess this would be the actual value that we're talking about, but yeah, whatever. Module containing value that represents, yeah. So //bang, top level document, it documents the whole module. So I suppose if you do like value equals import value zig, you will get the documentation here. These give documentation to the things you define in here. And then you have the normal comments. But there's actually, I mean, that's kind of common. Maybe not the top level document. I'm not sure. I guess it's also like, it's like built into the language, and some languages don't have that. Some languages you have to rely on some external utility tool to have like documentation like that. And then most IDEs would know how to parse it and give like documentation. But basically in Zig it's like built into the language. So that's pretty cool. But there's no block comments, which I don't know. I don't know about that. Because sometimes I do want to have block comments, but now what I do is if I want to block comment something out like this, let's say I want to block comment this out. Instead, what I usually do is I just comment it out, and then have, you know, if you wanted to do something like this, for example. Zig is good at like you're kind of molding into the way you need to program in Zig. Because it is a little bit different. All right, so here we got the array thing. We go through each element, and then we actually just call the initialize main here recursively, and then the ref the initialize there. Okay, good. Yeah. So that's the initialize main on the value. Now we can just call that directly instead, so we don't even need to do anything here actually. We don't even need this whole thing, to be honest. We could just call the initialize main directly on the value. Actually, we could just call it directly on the binding. So the initialize main, but we need these implementations here. I'm not sure how good this pattern is, but this is what we're dealing with right now. Oh, this doesn't work though. Oh no. Oh. Okay, this is one of the issues here. Like, because this deinitialize, this is actually a ref, so this doesn't have the concept of different deinitializations. So what do we do here? We know that this is a value inside. It's a binding value. Like, I might be going... I killed him? What? No, I don't think so. It's still here. It suggested it was in another place. It looked like I was maybe deleting this, but I wasn't. I was deleting another place where it was basically similar to this, but yeah. Okay, what do we do here? No, yeah, this should just be like the main. But then this is the issue here now. This is like a barrier here. Can we hack this somehow? We can like get the inner part. A pointer. Let's get the pointer. So this is the binding value. Catch unreachable. We're just gonna catch unreachable on this. As you can see. And then we can call the init main on this one. However, I guess we could add like a special dinit on the ref that wouldn't call the init on the child, because it's already released. Yeah, the ref, basically the ref gets invalidated at this point. So actually, we should just force a dinit here instead, which will call. But this is the issue now, because this will call dinit not dinit main. So we could have like options here, dinit options. And dinit child, I guess. Oops. And all this does is deinitializing the child. So if we don't need to deinitialize the child, we don't do this. Pointers null, ref 0, destroy. Yeah. So deinit child. Let's do like if options deinit child and that. And yeah, let's force this. So now we can say false here, which means that we have to take care. We're deinitializing the RC, but we have to take care of the value inside. Okay, that works. And then we're now deinitializing main. It does mean that all other refs to this will get invalidated, but that's fine, because when they call deinitialize, they will just, it's just you know, if logging is enabled, it would just be like a warning. Okay, and we deinitialize main on the value. Yeah. Okay. So we don't need scope now. Yeah, because we are just use scope to log stuff. That's right. Unused constant pointer. Oh, we don't even need to do this. We just need to dinit main on the binding. There we go. And you don't need scope. Okay. Oh, shoot. Well, okay, let's just wrap this. Actually, we could put this in the init child. if the init child and release the init child should be true. All right. Cool. Just want to make sure. The mutable. This gets the pointer. We initialize this without initializing the child. Yeah, so we never call release, but that might be called in other places. That still refers to this RC. But then it would see that this is deinitialized, so that won't happen. Okay, okay. Yeah. Okay, so something happened, but then we still log stuff out here. Weird. Okay, we got double free, and we got some weird stuff. God damn it. Man, it's really hard to keep track of everything here. Constant hello function. So this would get deinitialized, but not yet. Why is this like this already here? Yeah, this is the function declaration there. The function, where are you? Here, we initialize main. That initialize closure first, and so initialize the binding, and then we clear it. And while doing this, we it's a constant. We free name first and then initialize that. But it's gonna be a double free anyway. Okay, so now the issue is that this gets double initialized. Man, I thought having RCs would solve all the issues, but it didn't really. I still feel like there should be a way to not have this deinit main, but to try to go like from inside out and then unroll everything and deinitialize from inside out. But there's so many barriers in the way, it feels like. Yeah. Mm. Because really all we need to do is basically go in and release all the scopes that we can find. So maybe the scope iterator was a good was a good alternative instead. Going through all the scopes that is in one scope and then just releasing them one by one. But that's basically what we're trying to do. But then some of the things gets double freed here. But we use this like double main or the main instead. I don't really like this pattern. It feels wrong. And we have all these double implementations. So if we want to extend this, for example, it's gonna be double work everywhere, almost. It feels like. I mean, technically, what's happening basically is that, I guess, when we initialize this function, we also deinitialize. So we're back to square one basically. We're trying to deinitialize the function scope, the closure, which is this one. This is the closure here, and this one has, you know, the function itself in it. So it was going to be like an infinite loop basically before. Now we kind of fixed this problem. However, this binding is already like deinitialized here. So the binding itself probably needs to be refed. Like the mutables are... Yeah, the mutable is actually... Wait, do we really need to deinitialize like this? Yeah, because the release, the deinitialize on the ref actually... You know what? Maybe we should add options to deinitialize on the ref to not deinitialize the child. Because then we don't run into this issue where this would be double. Yeah. Okay. So let's add options here. Deinit options. We pass these to here. And you also need options. Deinit options. And we pass it along to you. There we go. Now we should get a whole bunch of errors where we just do this. And now I think what we do is we say this is true by default, and you have to specifically specify that it's not true if you want to have special treatment. Okay. Yeah, this one. No, this one we don't actually need to initialize the child. We already do it here. So the init child is false. Yeah. And this is the binding. So basically also here we do allocator destroy self. Probably. Okay, and now we can say here, we can say instead of doing this, we will do m.initialize. The init child is false. There we go. I mean, okay, maybe we could also set the init function actually. Well, not here, I guess. No, you can. You can have a pointer to a constant function. Takes an allocator. It takes t. Actually, I think it even takes a pointer to a t. Because we need to actually destroy the pointer itself. This is a pointer to t, yeah. And we can say needs to destroy the pointer as well as well. So like custom the init function for child value needs to destroy pointer t as well. Okay. So, and then this will be just a void. And we'll initialize it to null. So now we can actually modify which the initialize function we should use, which is very good because let's say we want to initialize the child. And then the init function is going to be options the init child function or else the init child, except no, okay, pointer is the only thing we do. Well, we actually do this as well. Yeah, we should do that. No, wait, that's the pointer. What about ourselves? Oh, that we do here. So we actually don't need self. Well, okay, let's just do this. Let's do like if options the init function, we get the init function here, and we call it with self pointer self allocator. Otherwise, we will call self init child. Okay, now you can modify whatever function we pass in there. So we have the init child could be true now, but now we can say the init function child is gonna be bind. Let's see, because this type is a, god damn it. Mutable is a binding value. So this would be like binding value deinit main. So we're setting the deinit function. And then we don't need to deinit main ourselves. We just deinit main if the ref is the last one. So now we don't actually deinitialize the value until it's the last one. So we shouldn't get double deinitialized now. Hello, Noctu4. Hope your Saturday is going well. Thank you. Same to you. Welcome here. What are you up to? Okay. Good. What do you want? Options, init options. Oh, I see. Yeah, that should be fine. And you also want that. Okay, this one is the same. So, okay, I think that basically solved this whole issue. We just call deinit, and I would say the function should be scope stack dot deinit main. Oh, except this doesn't follow the type there. I guess we could add, so either we could change, we could add another one without the allocator. With allocator. So if we have, or it could be like a union, maybe. The init child function is a union enum, oops, with allocator. It's gonna be this, or without allocator, it's gonna be this. There we go. Except we don't have a reference, or I mean a default value. You are nullable, so we did null. There we go. And then let's add functions. So this is where the convention with the snake case versus Pascal or camel case, I mean, comes in handy, because now we can have like the field is called with snake case, but the function is, so you don't have to have another name that you come up with. You can use the same name but with different casing style. Just enjoying a slow Saturday morning. Nice. Yeah, I like taking it easy too. With allocator, so this one is going to be yeah, we just take the function here, the init function, and it's gonna be this type, and we return this. What the hell? And it's gonna be with allocator, the init function. Just a convenience, because otherwise you would have to like create a struct thing, and you would have to wrap, like you would have to say dot with allocator is equal to the function. Here we can just say dot with allocator directly. So that's a lot nicer initializer. Now here we get the function, and now we switch on it. And either we can have with allocator, or without. Now we could also be super fancy and make like a, maybe we can make like a dot call with child and allocator, and there was switch on self, and it's with, we will get the function here, and we will call it with child and allocator. Otherwise we have without, and then we don't pass in the allocator. There we go. Okay. And then down here, instead of doing this switch thingamaroo, we can call the init function, call with self pointer and self allocator, just to make this a little bit easier to look at. All right. Now we have a way to set that. So let's go back to the scope thing. Now you should be without allocator. There we go. Very good. What's happening here? Binding value get pointer. Oh, we don't need to get the binding value. The binding value there. Now, are you with or without? You are with allocator. Cool. We can also do this a little bit. Okay. Oh. Right, this ref is actually like a pointer to a pointer scope stack. Does that even make sense? Maybe we should just change this to be not pointer. Pointer. You need options. I'll be back. Alright, Penguin. You need to be pointer now. Wait. Expected type scope stack found this, that, and this, and this, and that. Huh. Now we're initializing a new ref. Yeah, I guess it makes sense. We just... Except does it make sense? Man, my brain, my poor brain. Right, this is the thing where like we're initializing with the thing. Also, now when the ref gets deinitialized, the whole scope gets deinitialized. I guess that's why. I guess that's what we want actually, but no. Yes. But then all scopes need to be referenced. Oof, that's gonna be a whole that's gonna be a lot of changes. Oh man. Okay, maybe we can just hack it here. I mean, maybe we could just copy it actually. Maybe it's just copyable. No, we can't. No, I think this whole thing is so weird. This probably needs to be refed as well. Like all the scopes probably need to be refed. Unfortunately. Everything else basically is like arrays are refed, strings are refed. This is not refed, but it probably should be. This is not, which it probably should be. Yeah. Yeah, we should probably make all scopes refed. Man, okay. Alright. So let's just okay. It's just gonna be so many changes. But it's probably for the better. I don't know. It's just so convoluted when you're trying to deinitialize the whole thing. Like it works well until you want to deinitialize everything. All hell breaks loose. it's just gonna be so many changes. I'm not gonna be able to finish that today, I don't think. I kind of painted myself into a corner there. Unless we can fix this somehow, just hack it. Because this is gonna get pushed as a scope ref. We're just running the function, and then we pop the frame out again, which will deinitialize the scope ref. Right. And that in turn will, so basically here, like we pop the frame, we deinitialize the frame here. So the scope ref gets deinitialized, which will, like, it will deinitialize the, I mean, okay, maybe we can make a special scope ref. Oh, excuse me. Maybe we could make a special scope ref just for this, just to make this work here. We'll make like scope ref special. Oh man. And then this would just be scope stack, which we will put as scope ref special for now. And scope ref special, we don't actually like deinitialize. We don't do anything with that, actually. All right. Holy crap, there's a whole bunch of stuff. Okay, deinit main. No, we don't do anything either, I don't think. Well, I guess we'll find out. We're not supposed to have these in deinit main, to be honest. Actually, we might have if you define a function inside another function. No, but that function then gets deinitialized as well. Yeah, no, I don't think there's, I guess we'll find out. Holy moly. Okay, log bindings, fine. I mean, here we can just, we can change these to print, and then s. Why do I have a space there? And then tag name, whatever it is, this self. And then we don't need, I mean, we can do this actually. Yeah. We don't even need a separate thing for that. We can just do this. All right. Or yeah, there we go. Special. Look up. That should be fine. Speciale. No. Find in frame. Closure. we just forward it. All right, you are now special, and you should now work. All right, now we just do this actually. There we go. Very descriptive. It's I should comment there. It's like temporary or something. What is this now? You want the init options? Okay. Right, because you're a ref. Right. Same thing here. Oh, actually, right. Okay, actually here, this is pretty cool actually, because this array, like the init value, like, okay. No, wait, no. I just realized that this is the same issue here. Like all these elements will get initialized next time the ref, if the ref tries to deinitialize it, it will fail. So we should probably have like child false here, so we don't do that because we already deinitialize these things. And then but then we don't actually deinitialize the actual child pointer either. Maybe we should just do it here then. Yeah. We just free array here. Yeah. All right. Oh, no more errors. Okay. No, of course it doesn't work. Oh man, we still get. Did I miss something? Okay, this one goes in here, tries to initialize the closure, but at this point the binding is already there, so that shouldn't happen. Why is that happening? This should only be called when the last ref gets removed. And the function closure itself should have a bunch of refs. This is like the ref of that. If we have a scope ref, it does that. Oh, no, but this should be fine, I think. Okay, and then the main. We have the init main on binding. Where's the frame init main? Oh, it's not public again. Right. So we have a single. We go through each binding. We init main on the binding. We clear the binding there. Maybe we should clear it before. We should just take it out. Okay, let's try that. Let's do like bindings, items, to owned. And this could of course fail, so let's just catch. Okay, now we get the bindings out of that. We can loop through those now. We don't need to clear the capacity now. There we go. So next time we go through the same kind of bindings, it should be empty. Okay, I think that improved things a little bit. So, initialize main. We go in here, initialize this child. Very good. There's basically nothing to initialize here except for this frame here. And then we have a binding that we release. No left. Very good. Initialize. But then we still get leaks. Yo, Penguin, welcome back. Okay, so it's an RC. Which RC is this? It's probably this one, but this one got the initialized. Oh wait, oh, right. I think, yeah, it's the pointer itself. So this, well, which one is this? This binding? Okay, the binding, the pointer to the binding itself didn't get cleaned up. So we're deinitializing main on the binding. This does call destroy on self. All hail arena allocator. Yeah. True. I mean, maybe that would solve the whole issue. Actually, that is very true. That is very true. Yeah. It's just, I think we need to kind of do this anyway, because we need a way to like remove an entire scope. I mean, I guess, you know, technically we could just use an arena for the whole scope stack. But the problem with that is that the arena is not really good at, if you're like allocating a bunch of stuff and freeing in out of order. So that's what the problem is there, I think, with that. You would need a more advanced allocator to be able to like fill in the gaps there. So that's why the arena doesn't really work here, actually, unfortunately. Unless we could like modify kind of like the page allocator to work with the arena somehow. But yeah. Can't you have another allocator on top of arena? I don't know. The problem with the arena is that the arena, like every time you allocate with the arena, it like increases the size of the arena, and so it's not really good for long-lived things. Unless you free it exactly in the opposite order that you allocated, then you could have that, but you know, we probably don't do that here, so it doesn't fit very well here. And having another allocator on top, I don't think that, I'm not sure if that solves the issue, because it will still use the arena allocator at some point, and that will still increase the size of the used memory thing in the arena. So I'm using page allocator, or I'm going to use page allocator anyway, in order to have like a bunch of loose pointers basically, and you can allocate however many you want, and you won't like run out of memory. And then you can free to get back memory as well, which is not the case with arena. Hello SQF. Welcome. And hello Vincent as well. Welcome. Man. It just feels like this should be solvable. It's just... Yeah, the pointer itself isn't destroyed. It should be destroyed here. That is very strange. Bindings, ref. Binding. This is the list of bindings and not the one binding. Oh, it is the array list. Oh, okay, okay. So it's actually this one that does not get cleaned up. I think we can just do this. Probably. Okay, yeah. And you're a single. You have the init, but not the init main. But then we can pass in options. No, wait, that's the wrong thing. No, you're just a ref. No, it's the array list, right? The array list. Okay, so that doesn't really work. We need to like make a special init function for single. In that case, if we wanted to pass it here. No, okay, so let's just not init the child. But what we'll do... No, because we do to own slice here. Oh, I see. So the pointer to the child is never deinitialized. That's what's going on here. Right. No, but actually this should work. We should just be able to remove this because it doesn't have any items left. So it wouldn't try to go into the items. It would just try to deinitialize the array list as is. And then also destroy the array list. Yeah. Whoa! Thank you! Oh my god. No, wait. Oh, that was the... okay. I thought we had like leak memory up here, but okay. Oh my god, it works now. I think. Anyway. Okay. Okay, we still have like the RC logging on, so let's disable that. There we go. Okay, we're able, again, to declare a function. That was what we did. We can declare this function. And let's try to run it now. Okay. How much do you bet this works? Of course. Of course. It doesn't even print anything. Okay, well, that might be because of our function. The function running code hasn't been adapted yet. So this makes sense. Let's go to... yeah, we still get the... okay, we're back to square one, basically, because this was what I was kind of... This error was what I was encountering when I first started to like refactor the scope. So we're basically back to square one there. Okay, so let's go to evaluator, run function. Somewhere we have that here. So you see, this, we kind of changed this a little bit. So before we had like, I made, yeah, we're kind of grabbed the document and it got like its own script executor and everything. We don't need that because now everything that we need is in the scopes. So here, like all the functionality we need to run a function in like its own context with the closure and everything, we just use the scopes. So we have a blocking scope, we do this ref special thing, we have a frame forwarding with the pipes here, standard out, standard error, which we then store in this here. Now we need to adapt this to allow for streaming as well in functions. We do have it for pipelines, however, not for like multi-stage pipelines, but for one-stage pipelines. And then we have a normal frame thing here that gets deinitialized when we pop the frame over here. So we pop 4 frames. So every time we like run a function, we have to create these 4 frames. And then we go through the body, which could be a block or an expression. If it's a block, we have a bunch of statements that we run, and we deinitialize the value directly here because otherwise it would leak. Same thing with the expression. We don't really do anything with the value right now. What to do with these values? I have another to do that says exactly the same thing in another place as well. All right, so yeah, so that's what's happening with the function. I'm not sure why it's not. We don't get like the result like we do. Have these riders that we should forward to, and then we get these allocating things. And then we're using that over here where we basically, yeah, we're duplicating this. Now you could do this. You could also use, you can also say, what is it? Standard out, allocating to own list as well, or to own slice, which will do the same thing here. There we go. Maybe that's better. And then we don't really need to deinitialize, although we could do that anyway. If something goes wrong, it will deinitialize anyway, so. Or it will deinitialize now when we have these statements. So we don't get a bunch of leaks there. I don't think this will solve anything, but at least yeah, we've gone through this a little bit. I'm not sure why this doesn't also like bubble up and print this thing. Oh, you know what? I know why actually, because it doesn't work like that anymore. Yeah. So how it works now is basically, well, we have these riders, but we don't just return the value anymore. What we do is like after, when we run the statement, this will get like, this statement could have things that push things into standard out, for example. Then it gets written into here. But really, we don't need this because we should already have a forwarding scope from outside when we run the function. So actually, we are not the ones deciding this. So actually, we could just remove this and let's see. But then down here is basically, you know, it's kind of weird. Like right now, we don't really get this standard out, standard error, but it is stored. Like if you have a variable, the variable itself will actually get the standard out, standard. It will capture it. Otherwise, it would just get forwarded. So really, there's no point anymore to return standard out, standard error here. But I will do it anyway because that's how it basically works right now. So I will just do this for now, and we'll just duplicate an empty just to make the type system work here. It won't actually duplicate anything, but it will create the correct type for us there. Because if we return like just a string, just this would actually be like a constant string. But if we dupe it, it will like turn it into like a mutable string with 0 length, which makes a lot of sense. Okay, so we don't really need to push a forwarding frame here. So we can remove that and lower this by 1, because now we have only 3 frames. Okay, now this would technically maybe work. We're out of... Okay, well, we still get leaked memory, but let's see if we get the output now. No? Man, I thought we would have gotten some output there, but okay. Okay. Fine. Okay. So, actually, you know what? This is also like evaluate pipeline, actually. I just realized. We are evaluating pipeline as well, which will run the stage somewhere here, or run the pipeline, I mean. And we have a bunch of these things, and we run the stage. And this is a function, but also an executable. So first it's a function and then it's an executable. And I guess we run the function and we get standard out, standard error. But this one will actually forward it for us. So unless we push any frames here that we shouldn't, we should be good. I don't think we are. So that should forward it. Okay, but let's check the executable actually, because this could change things. Now you see here, we have a buff writer. Those are only used if the mode is not streaming. Can a linked list solve this? I mean, we already had all the things in a tree, so you know it was already we could already access everything. It was just a matter of tying up the knots correctly. It was kind of difficult with the way it's set up, but you're a single, the stationary truth. Standard buffer. Yeah, so these are only used. These are like, you know, in memory. You get a writer and you can write to it. It will allocate new memory as needed, and it will put it in memory. So it's basically an in-memory pipe, you could say. And let's see. We spawn the thing. We have standard in, which we don't really have. We don't have streaming for that right now, but I will just ignore that for now. And here we get the standard out pipe and standard out pipe. So these pipes are the outer context where we should forward things to. And here we have the readers for the child standard out, which we are reading streaming here. And then we check if they are closed. So this is the whole streaming functionality now. So here is the important part as well. Like if we're streaming, we are using standard out writer for like the outer context. So it will directly forward it out directly. But otherwise we will just write it to the in-memory thing. So it wouldn't get forwarded out until it's done, if it's like a non-streaming mode, which makes sense. If it's not streaming, we shouldn't stream it out directly. We should store it first in the memory and then push it out. Neovim kind of made me fast while programming. I did set up LSPs and docs and also highlighting autocomplete. Oh, nice. Yeah, I mean, what I like about it, like all that, I mean, to be fair, all that exists in VS Code or whatever as well. But what makes Neovim really nice is, like, to me at least, is like the, yeah, all the, like, you know, keyboard commands, all the built-in like Vim command stuff that you can do. But also, of course, Neovim with a Lua config, you can very easily make your own like plugins and configuration and stuff, and very easily make like mappings and things. Just very easily make things on the fly as well, like macros and everything. So that's what I really like about Vim, compared to other non-Vimy editors. Let's see. Okay, so yeah, so this is just logging out the thing, and here we have like the loop where we try to see if we have this. Basically reads from the streams, and we're streaming it out from the reader to the writer. We get a bool back if it closed. I made this function here which will do that. So basically we're using the reader stream into writer. This is a built-in function which will just take whatever's available in the reader and put it out in the writer. And they can also have, if you want, you can put some kind of limit to it. Now I have like unlimited here. And if we get an end of stream error, I return true. So this one returns true if the stream closed. Or if we get some other error from reading, we return that error as well. And then if we had any kind of byte stream, which you get from this stream function here, built-in function, we will flush that out to the writer directly. So it will immediately stream it out there. And then this wasn't closed, so we don't close it there. Now, actually, I wonder if we get this, even if we did get some. No, I don't think we get like end of stream if there was bytes to read. I don't think so. We only get this if there was no bytes to read. I'm pretty sure. We would have to go into the file reader to find out. But okay, and then this gets flashed. So so back here. So I'm basically saying like when both of these are closed, then we will break. So that means that the child is basically turned off, and we need to call child wait for it to actually terminate. And then we gather the standard out, standard error here. If we owned it, or I mean, no, if we're streaming here, then we have already forwarded it to where it needs to go, so we don't actually get anything here. If we have a non-streaming, we actually now have it in the buff writer, like the in-memory buff writer, and we just forward it everything at all the same time here. And then we can also grab whatever standard out result will be, and we will put into here. So if we're streaming, this will be empty because we already forwarded it and we didn't capture it. If we, which we could do, I don't know yet if we want to do that. But here we store it as well, like in standard out own, so we can maybe use it later. We don't really need to, because we already forwarded it here. So really, we don't really need to like get the results. But yeah, anyway, and then the same with standard error, and then we return this thing here. Now, yeah, so I don't really know why this doesn't work. This did work before, so maybe I did something to break it. We get these logs though, if the executor log is on, so maybe we should just enable that and see what's happening. All right, we get a lot deeper deinitialization here now. This is the whole scope now. We can see we've got a bunch of frames, and then we get another scope stack here with a bunch of frames. That's the child there, and then we have another frame, a single frame there as well. I wonder why that's not popped actually. Like, I think even these two should be popped already. Not sure why they're not popped. Like, we're pushing 3 frames, but then we don't pop anything. That doesn't make sense to me. Like, these initial things, they don't pop. We just deinitialize them, I think. But here we have a bunch of, yeah, these 3 is like, they are always there in the start. And here we have a closure, that makes sense. And then we run a function. Oh, so we never pop from the function. Is that the issue? Run function. So we push 3 frames and then we never pop them. Yes, we do. What the hell? Or we should. Push frame. All right, I'll just BRB 1 second here. right. Why is the pop not logging out? We are doing this. This should log it out. So I'm not sure why this is not showing here. Run function, like we are in run function. I'll just remove all this crap here. We are not ever gonna go back to that. Okay. Unless like there's an error, but that should have been reported then. Yeah, it's like after this, it just exits. We get a leak. Is there an error somewhere? No? There's no error reported. What is going on? It's like we're doing this, right? It should also say what we're doing, like run statement. Let's actually log this. I forgot to add the logs here for these, so I'll just add that. Some of them are like execute expression, evaluate expression. They happen like always the same, but whatever. It's nice to have a complete picture. Okay. So we're running a statement, executing, evaluating pipeline. We run the pipeline. What is happening here is like evaluating pipeline, and then it's evaluating expression, evaluating pipeline again. I'm not sure what's going on here. Oh, I see. At first it evaluates this pipeline, and then we evaluate this pipeline. But that should be like a run function though. Yeah, we already evaluate the pipeline here. Let's include some more information here. We should have like the name available. Wait, where is that happening? Oh yeah, it's like this. Okay, I guess if it's a pipeline, we can trace. Oh, I guess we could have just done this. We should have one stage. this will get us a string ref. Is it a new one? We need to release it anyway, so let's just do named initialized. Okay. Name. Actually, it's a ref, so we need to like do try and get. There we go. All right. Scopes. Oh no. Look up scope. Okay, I guess we need that. All right. Now let's see. We should get like the name of the pipeline. There we go. Hello. Is it me you're looking for? We'll do like hello. Let's do like if stages is more than one, this will be dot dot dot, else nothing. All right. Pipeline P, echo. Great. Now we can see a little bit more on what's happening. So we are executing hello. That's the function. Yeah. So we're creating a bunch of frames. Then we're running a bunch of statements, the pipeline. We're evaluating that, and it's the echo. And then we're evaluating an expression, which is another pipeline, which is P. Oh, I see. Okay, now we can understand what's going on. Well, now I can understand what's going on. So we're evaluating this pipeline, the P in here. This is like kind of, yeah. We're like generalizing everything to a pipeline if we just have an identifier. But it eventually understands that this is just a... Actually, that should be like a final found. I'll just do this. Invalid free we get now? Okay. Great. So we're not out of that yet. Push frame. Right, so P is now the pipeline. We run the pipeline. And we run this echo executable thing. And we forward these things. There we go. Now we actually get this value here. Okay, cool. And then we pop a bunch of frames. Right, we pop like 4 frames here. So we pop the frame 5 single from main. I think this is like the function. And then we have this, yeah, this is the function scopes. We pop this. And then we pop the blocking. And then somewhere along the line, we pop this as well. Not sure which one this is. The forward context. Yeah, I don't know which one that is, to be honest. Oh, that's the executor, I think. That's the executor run. Okay. And then we just initialize this. We initialize all of this. So that should now, yeah, that goes and tries to deinitialize main. P and hello. And then we get an invalid free on the binding. So it's not double free, it's invalid free. Interesting. That usually happens when you have like a read-only pointer you're trying to free, or maybe freeing something that is allocated with another allocator, but I don't think we have that problem here. We should be using the same allocator throughout. So we get the invalid free. Do we have like where it was allocated? No, but it's trying to, okay, so scope 89. Right. So we're deinitializing some kind of frame here. Let's no, not log bindings. I just want to log frame and then this would be I, frame I, and we'll also take the tag name of the frame as well. Oh, this is the other way around. There we go. And we'll catch you. There we go. Okay, so now we should log out which frame is like currently being handled. We got a bunch of pop frames. So deinit main. Then we're deiniting main, for context, nothing happens. So this is when we're doing the first single frame. So that is the outermost thing. I mean, I guess it makes sense. This is the only frame we have. Let's put scope back in here, because I want to be able to log scope stack. I want to be able to log the thing. Let's move this in here. And we're going through the bindings. Binding. Sure, let's have a thing there. And the binding, we don't really have a good way to check like the type or anything. I guess we could try to get the value out. We could also get the name. I guess, yeah, I guess we do have the name. Then we don't really need an index, to be honest. Let's get the name. Catch. And then the value. Let's do like null, I guess. So this will be like value or null. Okay, and then we will show binding. And the type. I think you can do question mark, like if you have null, you can do question mark s if you have a nullable string. But we don't have a string. Value type if value tag name, else null. Now we have a null string. This one is also end string. There we go. Let's remove you. And let's do name and value type. There we go. What's this? Oh, right. Now we don't need you. And oh, okay. We don't have the I here. I guess it's kind of good to have. Let's just put the level here. So then we can also put it here, like hi. Yeah, because it's good to know which frame we're talking about. This is self. And this is scope log. Scope log. All right, there we go. Little bit more debugging messages. Okay, so init main frame 0, frame 1, binding p string. Yeah, so this is where things go wrong. And we get an invalid free when we try to deinitialize the binding itself and then destroy self there. Right, okay, well, no, yeah, so this one, yeah. Yeah, because the, oh, I see. Maybe the RC actually handles that already, or is, no, we don't have an RC for this one. This isn't RC. Why will this fail? Is it this one that fails? 2, 3, 6. Yes. Invalid free. So is it like a double free or something, or at this point maybe the pointer was set to something else? Why is it called a ref? Oh, it is a ref. Now what is the bindings ref? Yeah, and so at this point it shouldn't have any items in it, because we're removing the items here. So it shouldn't have items. So it shouldn't go in and try to deinitialize the children. That should already be done here. What is this pointer coming from? Wait. Is it because this goes to own slide? Wait. Is this binding ever actually created? Where is that? Declare. Right. It lives in the array, so we don't need to destroy it. We don't need to destroy it here. Good. Oh, we get leaks. Which one is this? Okay, I just want to go through here and see what's happening here. So we pop all the frames. We initialize the main. We go through and initialize this. We initialize the function, which triggers initializing the closure, which initializing everything here. Okay, cool. So that should cover everything there. But there's something else being. It's bindings append. So the bindings itself, like the list itself, never gets initialized. Scope declare. Yeah, it's not the item that is the problem. It's the it's probably like, since it says append, it's probably like reallocating the children to accommodate for more like things. So it's basically this part, like this should take care of the array, but I guess it's not. Oh, wait. Well, we don't really have a scope ref though. No, but this one is the init main as well. So which one of the bindings is it that gets leaked? Evaluator 1190. It's one of the bindings. Okay. Yeah, it's one of the bindings that triggers the reallocation. But really the whole bindings array should be initialized here when every other reference is also released. So it tells me that something's wrong with the RC. So let's go to the RC, enable logging, and let's look at this. Where is, wait, did it have time to rebuild? Because I don't see any RC stuff. Here we go. So so we should see at the end somewhere. We have the binding list here. Init, it gets deinitialized. However, we could have another list that doesn't get deinitialized. But it's just this list that doesn't get initialized. Which is weird. Like the RC gets cleaned up, but the inner part does not. Does it not detect that it's an array list? Yes, it does. It does detect array list. But also, it's kind of weird because we are doing this, so we shouldn't even need to deinitialize it. It should already be deinitialized at this stage here. To_own_slice does, like, it removes the caller, owns the return memory, empties the thing. Wait, are we never deinitializing this? Is that the issue? That's funny, Blue. What does source do? It gives you information about kind of the context in the source file you're in right now. So you can grab, for example, you can grab the function name, the column of the source code at, I guess, where you called source, the file line, and the module. So it's a nice way to, when you add like debugging messages here, that you don't have to like type out the if you have like different function names. So it's nice to have like a little bit of context. If you're making a scripting language, you will call it Zag. That is funny. Okay, so we're freeing this now. Was that the issue? Maybe. Let's man. We need to have a whole bunch of tests here. Oh my god, now it works. Okay. So this works now. We can grab stuff from the outer scope. We can put it in here. Let's also try this. This is P. And then we set P to something else. P is something else now. And then we call P. So P before hello. P after hello. Oh, and of course we get leaks. Man, it never ends. It actually never ends. Okay, well anyway, this works. Hello, this is P. P is something else now. So it does work. Maybe it's like the reassignment or something. Man, I feel like I've already went through this like a couple of times. But yeah, this works. This now captures this in a closure. The function captures the outer scope in a closure, and it can also reassign this reference here. And so, yeah, it works. You always wanted the in C, you mean? Like the source thing? Okay, let's enable this, and let's enable the runic logging thing. Let's see what's going on here. We're leaking this thing. Do we have it anywhere? No. It's only... Which one is it? It's the child here. Okay. We're declaring something, right? I wish I could know more information here. But apparently some RCs, well, it's not really the RC. The RC seems to be actually cleared up. It's actually still some binding here that's not... Oh, this is the init now, actually. So scope 392. Now this is different because this is the ref, I think. This is a ref. No, it's the binding. Oh, it's the mutable ref, I think. Maybe. Yeah. which initializes some inner thing. Should this be like dupe? No, it can't be dupe because we're not duping anything. This is init for a binding, but that does not get declare. Where is it called from? Bind pattern 1190. How does it detect leak? It is a special kind of like debug allocator that will just keep track of every allocation you make, basically, and then at the end it also keeps tracks of all the frees that you make. So basically, at the end, it will just compare, or it will just check like which one you didn't free, and it reports those. And it also is pretty nice because you get this whole stack trace as well. And a lot of information about where it was leaked from, or I mean, yeah, where it was allocated. So, and it also detects things like if you double free, for example, and you get both locations at where it got freed. So it's pretty nice. It keeps track of all that. It's really helpful to find where the leaks are and how to solve them. Okay. So we're calling bind pattern. Why does it like stop there? I wish it would keep going. Because I know there's more to the stack here. It doesn't stop there. Why is it stopping here? Where is this call from? But this declares something. I wish we could see also what it declares, like which. I mean, we do get the pointer, so that's good. And what we could do is we could when we create the RC, like when we do this, we could also log which RC created which pointer. So if we go to RC and we will do something in it. Here we create the RC, but that was not, it's in it inner, I think. Yeah, RC 138, so it's this line here. So we're creating this, and then I want to do let's do this instead. Oh, wait. We don't have an RC yet. I see. But let's create an RC. Return it, and then we can use the logging here. Right? Alright, you're an RCT. Now we can log. And we can say no source. Alright, have a good one, Penguin. What if there was a function to toggle on the garbage collection free automatically, like for debug stuff? Well, the problem is basically that even if it did that. I mean, that's not really the issue. Like then it would basically be like an arena. You know, when you exit the program, all memory that you've used is going to be released anyway. So that's not the issue. The issue is if you have like a long running process that will constantly, you know, allocate new memory, free memory, new memory, free memory, and so on. So you want to make sure that you don't have a leak, because the longer the process lives, the more leaks you will accumulate, and at the end, at some point, you will run out of memory. So it's just a way. It's just to make sure that we don't like run out of memory on a long running process, basically. But if you just have like a one shot program, it doesn't really matter that much. Like you can allocate and leak all you want. It's just to manage so the memory usage doesn't go, run amok, basically. I do think they can improve printing errors. It's so raw. Yeah, a little bit. It's fine. You do get used to it a little bit, but yeah. You have to always, like when you're looking for like the leaks and stuff, you have to like squint your eyes a little bit and teach yourself what to look for. Like these little messages. Like this is very hard. This is very hard to actually spot when you're not used to it. In all these logs here, sometimes you get like 100 of these, and it's like, okay, where do I start? Where do I begin? Like, but yeah, you can also just search for leaked, and you will get where you want to go, basically. But yeah, it's a little bit hard. I wish this would be like a different color, so you can see it better. But yeah, you do get used to it, so I can now see this a little bit better. But at the start, it was very, very difficult. Yeah, colors. But I mean, it's very informative. So I really like it. It could have been worse. Let's see. What do we want to do here? So we initialize that, yeah, and then we want to also have the pointer to what we actually initialized. Created and this would be pointer. There we go. So now, if we now look at this memory, we should here see exactly where it was created. So this was created up here. One of the first things that happens here, I guess. Well, this is the... Oh, so it's one of the binding values. Yeah, it's the mutable binding value. So then we can use this kind of like an ID to see where this gets released. Then we can see that it doesn't get released anywhere. Okay. Oh, there's a lot more like ref stuff happening than I realized, than I thought it would be. I guess it's like all the strings and everything. Hello, this is P. Yes. Yeah, okay, so it will live throughout the closure lifetime. So it should it should have gotten the initialized when the when the scope gets initialized. So over here it should get initialized here. So this one gets like initialized, and then this closure should get initialized. Binding P gets the initially released, but then there's what? Hang on. You're created there. Oh, I see. Maybe that's the original. Yeah, that's the original thing. And this is the the function execution scope, I think. Okay. Right, so we're initializing P here. That's the original, which gets released, but not deinitialized. Well, it does get deinitialized. What the hell? I'm confused. Right, and now this is the closure. Wait, I think I know what's going on. Maybe. When we create like a scope ref, the closure, where's the closure at? The closure, we create a new scope stack and singles get refed. Yes. Okay, I think I have a major flaw in my structure here. Maybe. Yeah, I have a major flaw. And that flaw is that this ref is supposed to keep everything in it, you know, in memory, because it's supposed to, it's like a strong map or whatever. It has to, everything that's in here needs to be kept in memory. But we're just creating a ref of this like container. It doesn't create refs of the things inside. That's the issue here. However, I don't understand where but that would be a different error though. Like this leak here, I don't really understand where this comes from to begin with. Hey, can you try to imitate the JSF rules, like JSF compliant zig? What is that? JSF? Joint Strike Forces. Okay, what is Joint Strike Forces? Air Force Programming Rules. Okay, what is Air Force Programming Rules? Sorry, I have no idea. Never heard of JSF plus a plus? No? Is it like, I mean, is it a real thing? Is it some kind of joke language or?
I don't know, I have no idea. After it gets popped, we create this inner... Is it the closure being created here? Maybe. It's probably the closure being created, but when we create the closure, we don't actually... It should say like push frame though, when we create the closure. I should add this here so I can see it as well. Closure, we don't, well, sure, let's add that. We don't have a tag name frame though. A very real version of C++ meant to replace Ada. Maybe it's instead of... Huh. Interesting. I've never heard of that. And I've never, to be honest, I've heard about Ada, but I've actually never seen anything of Ada. So I don't know anything about Ada. But I guess it's close to C++ if you can make some language with that. How can I avoid recursion? Use loops. Loops, and sometimes you need like a dynamic list. I actually used in my stack or in my expression walker, like that walks the whole AST tree. I don't use recursion actually. I use a stack where I just push more expressions in that I need to walk through. I guess it could be recursion somewhere in it, but it's like the whole point is that I didn't use recursion. I used this list or the stack list instead. Hello, C program lover, welcome. Avoiding recursion is the main part of JSF standard. Interesting. Okay. I mean, I don't mind recursion. I mean, I think you should use the correct tool for the correct job. But I guess if you could make some like optimizations by keeping to a certain pattern, then that's fine as well. Yeah, try it, Blue. See if you can work it out. Okay, so we're logging that. Okay, here we're creating a closure. That's it, yes. So we're creating a closure. We're forwarding that. Let's see, which one is leaking? This one. Okay. Is this like the initial, like the original? Yeah, this is init with runner.
push frame. Yeah. Evaluate literal. Oh, I see. This is like a binding where we have the forward context for the binding. Yes. And this created a string. And we pop the forward context, so we're done with that. Let's look at the source code as well so we can see what the hell is happening here. Right, so this is the first one. So that is now over. And yeah, it's the original binding to P that is being forgotten. I guess it's maybe it's like written over or something. Okay, so yeah, this is what kind of what I was saying. So basically the issue is here. The issue is that we don't loop through all the bindings and create refs of them. We just create a ref of the array, but the children is still the same refs as they were before. So we would need to go through each thing in here and create refs of the children instead also. I mean, we could do it here because this already expects a reference. So we could create, we could move the responsibility of actually refing the thing by pushing in a ref, like by pushing in this instead of the ref itself. So this would be, you know, we'll do like this instead. And for single ref, we will do, so let's do like single ref equals single dot ref. And you're the new single ref, but now we also need to loop through and basically all the bindings. We need to like loop through all those. Get pointer. And basically reassign to a ref as well. So we're recursively refing through everything. So everything will get a ref copy. That does make a lot of more sense to me. Maybe JSF war embedded system for aircraft because they don't want aircraft system failed production. Yes. All right. Okay, so is it actually that? Is it actually like you know, thought to be good practice to avoid recursion and use? I mean, I can see it being maybe a little bit simpler code, so it's easier to reason about, maybe. And some of the languages, you don't have to do the like recursion optimizations and stuff. All right, so this one works now, and now we need to do the same thing here. So scope ref is scopes.ref. And what do we do with this one though? I guess we go through all the frames and copy them as well. Actually, what the hell? This doesn't work. This doesn't work because we're modifying the original. We need to like duplicate. We cannot do a ref. We have to duplicate. Oh my god. What? I thought about this totally wrong. Or did I? No, I think the problem is more like a ref shouldn't get deinitialized if we still have a parent context that also references it, I think. I think that's the missing link here. But there's no structure around that right now. There's no way to like get the parent. Unless we keep that in the RC. Ah, okay. So we have to have like a parent in here, I think. Man, this is getting... Okay. Yeah, maybe we could have a parent, apparently. And this would be like a nullable or optional. I always say nullable first because I'm so used to it. And this would be like a pointer to an RC something. I mean, what would this even be? A scope? It could be like attached to anything, I guess. Maybe it's like an anti-opaque. How would this work though? No, it would be the ref. It would be the ref that has the parent, not the RC. The ref has the parent. But what would the parent be? Just a bool? Or a pointer? So you could check the pointer value maybe. As like using the pointer as like an ID. So it has to be like a pointer to a container. It could be a pointer to anti-opaque. We just compare the pointer value, like the pointer address. Wait, how does this work? I'm just thinking like, what should happen now when we deinitialize the ref? How does the parent come into this? Because I was thinking like, yeah, okay, so if you don't have a parent, then we release it. We deinitialize the whole thing. But no. Okay, I'm confusing myself. Because you can have, loose refs, basically. The idea is that you would be able to have loose refs, but if they have a parent, question mark star means it can be a null pointer, right? Yes. this is breaking my brain right now. No, the problem is that when we copy the scope and we don't copy the bindings inside, they will still only be like refs. Maybe actually we need like a list of parents or something. I don't know, man. No, that would be so much shit everywhere. Like this almost makes sense here. We're just copying the whole thing. The problem is, what was the problem actually? What was the problem? The scope ref. We go through each frame. We make a reference to each frame as well. I don't know. Man, this is difficult for me right now. It's like, until now, like the RCs are kind of like decentralized references, you could say, which they have like they have a ref counter with the number of refs currently out there, and each time you deinitialize a ref, that ref counter goes down. But where is that ref counter stored? It's stored in a pointer that gets initialized whenever you create a new, entirely new RC. And then you can create how many refs you want to that. Those are basically just copyable structures that increases the ref counter by 1. And then you're supposed to release them when you're done. So they are kind of like decentralized refs. All right, SKF. I'll note that. I'll take a note of it. And I just want to walk through this a little bit because I might missed something here. So, and then we have these containers as well, the scopes with a bunch of refs potentially in them. Like each string is a ref, and the idea is that whenever something releases the ref, if it's the last ref, it also gets deinitialized properly. So the idea is that whenever a new thing is gonna wants to keep a ref, it needs to create, like, call this ref function to create a new ref, and then manage releasing that by itself. But the problem here then, what was the problem actually here? Because we're creating a new ref to the frame. That's fine, because it's gonna get initialized whenever this container gets initialized. We're creating a new binding. Oh yeah. The problem is the... Okay. The problem is this. This bindings is not unique to this ref here. It's actually shared between the ref. So we actually need to create a whole new ref. Actually, okay. We need to like clone this, actually, not ref it. We need to clone it. Yeah, we actually need a cloning method now. We're increasing our book of spells with a cloning spell. All right. Okay, so also I dislike this pattern. This is all better like this. Self RC or else. Return RC error invalid ref. That's a way better pattern. Because then you don't need this, you don't need to nest. And yeah, you don't need this if. Okay. So clone. Wait. What do you clone? We want, well, first we need to check if we have our RC. Then we basically say RC clone is RC clone with, I guess, the options then. And then we just return clone. How do we do it? We just call our RCF or RC ref with options. Wait. How do we do it for print? We just get this. We don't pass options in there. Okay, so I guess we'll omit the options to clone, but then we return RC clone.ref. So we create a whole new RC basically there, and then we'll try to clone the inner part. Can you hear something, or what's going on? Someone's calling. Okay, so we'll do like clone RCT, and we will get a new RCT. What kind of return type is A bang B? It's an error union. So it's like this type can be this error, or it can be this value. If there is an error, this value gets returned. If there's no error, this value gets returned. Or this type, I should say. This type should get returned. And this type gets returned. If there's an error. And it's called an error union because it can be either this type or this type. Yes, it is amazing actually. I would, this is like one of the many reasons why I would prefer this language instead of C. which just returns like a number that you have to guess what that means. No, but yeah, unless you need like you find it fun to read like a bunch of manuals all the time. I don't know. Anyway, I don't want to bash C too much here. Okay, so or you know, match it with some magic error definition that gets polluted in your scope when you include a file in your global scope. All right. What do we do here? So what do we do here? It's like this will depend on the underlying type having support for cloning, I think. Unless we just clone the RC and keep whatever's in there. Yeah, I'll just add a caveat here. Will not clone the child. Sometimes when you write sentences in comments, it sounds weird. Okay, so this will do. We will just initialize. Why is it called buffer? Oh, because of print. We will initialize init inner. Yeah, maybe we'll do this actually. No, yeah, that's what we're doing. Like we're calling init, and then we just provide the value that we have. Yeah. So this would be self pointer, and we should have it. So I'll just do this. Wait, do we have a usual like handler for that? Does it look like it? I guess not allocated. We could use this. Is pointer allocated? I guess. So we get a little bit of help. Something goes wrong. Return init allocators pointer. Otherwise, we will return error not allocated. Yeah, so basically RC error is my own error definition here, which is specific to RC. So this is how you define an error. This is like an error literal, you can say. Here is you can define an entirely new error. And this is called an error set. Or I should say this is an error type. Yeah. So this is all of this is an error type. This is also an error type, and this is an error type, and this is an error type. Now what this means is that we're kind of joining everything together into one error set. So then you have all of these like children, I guess you can say, like these are like the error kind of values, or yeah, strings that you can have as actual errors. So these are the actual like errors that you get. So you return not allocated. This is like an error, but then the error set would contain many of these different kinds of errors. And So allocator error, for example, has out of memory error, and that's the only thing it has. The writer error has write failed, and so on. So I'm joining all this together, and this is like all the possible errors that we can get in the RC error type now. And then I just say RC error everywhere, so I don't have to, you know, type out the whole thing every time. So it's just like an alias there. You can also omit the error to infer the error type from here, from the errors that can be reported here. So you will know, the compiler knows which errors you can have here, because all errors need to be handled either with a try or a catch or just return. So if you, for example, return an error here, yeah, that will be included in the error set that is like inferred here. But you can also do this implicitly. And why would you want to do that? Because then, well, for one, it's more clear what kind of errors you can get. But also, if you have another function that calls this function, and then that function has defined this error as RC error, and it tries to call this function with a try, it has to have the same error type. So that's why I have like RC error everywhere here. Even though I should probably like here, or some of these doesn't really have all the errors in here, so we could get away with like writer error only or allocator error only. But I just like having like RC error everywhere. It's just convenient. It's not really a huge deal if you... set up a formatter for Zig. There is a built-in formatter in Zig. It's built into the language. Did you see some unformatted code or what? It's not formatting until, I should say, it's not formatting until everything is like, every syntax error, every error is fixed. Then it starts to like format the code. So right now there's something like wrong somewhere. So this would be self allocator. There we go. Now you can see it kind of blinked. If I add a comma here, it will format it like this. If I remove the comma, it will format it like this. And it's all built into the actual language itself. It's not the LSP, it's the language that formats it. But I think the LSP is like using, or yeah, there's something in NeoVim anyway that's like calling the formatting thing. Okay, so let's see. Missing parent. Let's forget about the parent actually. I don't think we need that. I don't know what I was thinking there. I was like, wait, but the container needs to know like, or all the refs inside, or I don't know. But let's try with this approach instead. So, yeah, I think this needs to clone instead of ref. And because it needs its own bindings array, and so we clone it. That should be fine. I mean, we're still deinitializing all of the refs, like there's no issues there. It's just that we need to copy, or we need to clone the things inside. And then we also have to now do the things inside. So basically bindings still points to the same thing. So we have to create a new array as well. Now we have the bindings pointer, but I will say that this should be equal to bindings clone. Oh, we need the allocator. God damn it. I mean, we kind of have the allocator. We have the allocator here, I guess. Yeah, let's just make it. Let's make a convenience function here. Get allocator. Return allocator. And of course, we'll get all these counts of errors now. Wait. Why? Okay. Sure. So you don't actually need the allocator because we can just call allocator on self or try. No, I'm sorry. No, that's not correct. We don't have a ref. There we go. And same thing here. This is one of the things that I won't agree with in Zig. It's like the shadowing stuff. I'm not a big fan of that. Like, yeah. I've talked about this before, but I understand why they have like a very strict shadowing policy, but I think it's a little bit too strict. Just a tad bit too strict. Yeah. Like defining two identifiers in the same scope, I can agree with is bad practice. But if you have a sub-scope that shadows the outer scope, I don't have a problem with that. Personally. But I do understand the reasoning is basically for safety. I guess especially in like Bash maybe, but no, I'm gonna allow shadowing. It's just too convenient. Expected. Yeah, so this would be like single allocator. Yeah, so now we could just get the allocator out from there. We don't even need it, which is really nice. And try. All right, so we'll clone that. This will create a new list with the same items, and then we go through each item and we will create a ref from it, because it is supposed to ref the same item if it's like a reference to a string or something, but so it's kind of like yeah, it's a reference. So if you modify it, you will modify the original. But we did need to clone the frame because we did need to clone the array, the bindings array. So we did need a new copy basically of this frame here. All right. Now, how do we deal with the scope ref? This is kind of the same idea. Yo, Kuvi man, welcome. How's it going? So, okay, do we do the same thing here? Like I'm just, because this is like a scope ref. Yeah, I think we just do the same thing. We'll see if we end up with some issues here. I guess we need an allocator as well. And man, the RC just turned out to be such a huge I think it's just yeah, a huge win in this. I'm really glad I implemented it. It's really tricky sometimes, but I think it's a really good tool to have here. Alright, so we're making a new ref. We're gonna need to create a clone here as well. I'm pretty sure, maybe we don't need it, but whatever. It doesn't hurt. Alright, we're cloning that. What are you? You're a scope stack? What? Oh yeah. So you're the scope. Well, that's already cloned now. It's gonna be the frames. That's right. The frames. The frames. The frames need to be cloned. Alright, see you later, SQF. Okay, so now these are cloned. And we'll loop through them. IDMs. And now this is a frame. I guess this is kind of like the closure. To be honest, this is like a closure. Like we already kind of have this functionality in the closure function where we go through each frame, we clone, we create a new scope, we go through each frame, and then we, like, depending on the frame, we push the new thing. If it's a single ref, we ref it. Scope ref, we do that. I guess this is where we kind of initialize it, but we should probably just call this closure here, to be honest, because this does exactly what we want, actually. So yeah, okay, so we'll just create a closure. Now you are the ref. Now that's the original. This is the, okay. Let's call you ref, scope ref. And you are the clone. Okay. Just to make things work here now. We create a closure here from not the clone. We will grab the scope from scope ref get pointer, and then we'll create the clone from scope closure. No, this is the closure, yeah. We create it from the closure, and then we don't need to do anything else, actually, because this is like gonna get, it's gonna be like recursive. So what we need to do though is we need to init, wait, init, and the value is the closure, except this doesn't work because this is supposed to be like the value. We need to basically create an RC, but we need to like just put the value in there. This creates like a new pointer. I mean, we could just change this to be just a scope stack again. We don't really need it to be the thing. If we create a closure, then we could just deinitialize it, I think. The only thing is copied is basically it's the list of frames. And the refs, all the refs inside, I guess. But that we need to do anyway. Okay, let's just do scope ref or scope ref clone. It's gonna be like RC. No, that's a wait. What? This is a scope ref init annotator, and the value is closure pointer, and then we just destroy the closure here. Yeah. So we clean up this one, and we kind of move it. We move it into the RC, where we can put it here. Clone. Yeah, that's fine. Shadows declaration of closure. Really? All right. I'll just call you scope clone then. No, you're definitely an error. You need 3 arguments, right? There we go. There you go. Okay. No. Oh, hey. We've got a raid. Wait, do we get a raid? 3 days ago? What's happening? Raided you with a part. Alright, Kubi man. Oh, I see. That's what happened. Hey. Alright. I see now what's happening. Welcome, everyone. Alright. Okay. What is happening here? We are currently creating like a bash-like scripting language, and I'm fighting the memory leaks here in all the scopes and stuff. Right, so we have this leak here. A binding value. Let's see. Yeah, it's initialized and never. It's the same issue. What? So we didn't really solve anything. Okay. Yeah. So we have like a scope in the outer. We're creating a variable p. But then we create this closure, and I think this is where it gets like overwritten in the closure, perhaps. But yeah, I should check out. Like we have the closure function, and then we are pushing this frame with the bindings, and then we're going through all the bindings, and we're creating refs. But we shouldn't. It shouldn't actually overwrite anymore because we are cloning the bindings, and we're also cloning the ref. Hang on. Yeah, that's the clone. There should be a fresh copy here. We should really get. No, wait. This is the single actual thing. but let's get bindings original. So this is the bindings clone. This would be the binding original. And binding clone is what we need to populate. And then this would be the clone. Yeah, now we're populating it with the clone. And then we should go through all the clone items. I think this is basically what we did, but no. Yeah, it's the same issue. Like running statement, we're making a binding. This is the list of bindings we're creating here. Here we are evaluating a literal, so here's a string we get. And then we store the result in this binding, so we're initializing a binding, new binding here, value there. But then this never gets released or mentioned again, so it's probably like overwritten when we create the closure here. We execute a function declaration, we create a closure, and we're pushing a frame there, and we're pushing the single context there, or single frame, which will initialize the binding array again. So good, that makes sense. Although this is a new pointer, okay, and this is also like a new pointer there, or is it? Oh, this is binding value. Wait, the source? No, it references the same thing here. Wait, why is this ID? Why is this different? Why is this different? What do you mean by double scope shadow stuff? So basically, okay, so if in Zig, let's say you have a variable A here, or something with some kind of name like this, which is very, you know, a usual name for a thing, and then you have like, I don't know, if true return, like, and then you want to make a new result, and you call some function or something, you get some result out and return result. Now this is not allowed in Zig. You will get a shadow. It means basically that you're declaring a variable or an identifier that has the same name as an identifier in either the same scope or a scope outside. So this is the outer scope here, this whole thing, and this is the inner scope, and you can't have the same name even if they're in different scopes. And it also becomes a problem, like if you have a struct and for example you have like allocator, and then you have like, you know, init, and you get an allocator. Okay, I don't think this won't be an issue actually. However, this is not an issue. Like this is allowed because to get to this allocator you have to do like self.allocator. However, if you have a function called allocator, you cannot have a function called allocator now if you have self scope to get an allocator because of shadowing issues. So now if we say like return self.allocator, like we don't know which allocator we're talking about. Are we talking about the function allocator, or are we talking about this allocator? So this I kind of agree with. This kind of shadowing is like, this is really ambiguous. Like, which allocator do you mean? So you have to rename one of these, or that's what you need to do. Or potentially you could have like, I don't know, options, scope options, and this would be like some kind of, or just options, and then this would be some kind of struct with allocator in it, and then you can basically options, you can do this, and now we can actually do like self.options.allocator. So now we're kind of avoiding the issue here. I remove allocator there. We're kind of avoiding the issue. Okay, now here's another issue. You see that we get a function parameter shadows declaration of allocator. Now what is this shadowing? It's shadowing this, because if it's a field, you have to type self or something dot allocator to get it. This one though, you can just type allocator and you would actually refer to the function. So now it's ambiguous yet again. You cannot, if you have like a function that takes this as a parameter and then a function of the same name as like a function in the scope or a function in the scope, you cannot actually have this name. And this is where I think it gets a little bit overboard with this shadowing issues here. Like if I have a local variable, like a parameter that's called something, I would know in this function that that's what I'm referring to. I'm not trying to refer to this. And you can even refer to this if you want by saying either like scope.allocator. Now you're referring to the function, right? So that's totally doable, and it's no ambiguity there. And you can also do like at this, which refers to like the current type that's in the scope. So you can refer to this without issues, but you cannot actually do that in Zig now because there's an issue. So that's what I have a little bit of issues with the shadowing there, but it's fine. You just have to like live with it. Yeah. Yeah. All right. So we're doing a bind. I wonder where this comes from. Like we have 2 RCs. It seems like there's only one, but we actually get like several here. Why has the thing changed here? And then we get 2 refs. This is a binding value. I wonder if you can have a formatter for the type so you can get more information. I mean, we could just add more information if we want, but we could actually add like a generic handler, like generic like toString, debug string or whatever handler that we could add more context here if we want. But I don't know why we have 2 of these. I wonder why C need header files, but Zig and Rust doesn't. So, yeah, I mean, I guess it's because of the module system. Like Zig and Rust have module systems, well, C, you need some kind of way to talk about, you know, the symbols are linked in with some kind, like either you have like a dynamic link or a static link. And so when you include a header file, you get all those symbols in your scope, but it's not necessarily available. I mean, I'm not an expert at that, but from what I know, that's like how it works. It's basically you have to you have to either link a static library with those symbols available, and it would basically just string match basically those symbols almost. And yeah, so it's kind of magical, to be honest. Like the module system, like modern module system, makes more sense, and you don't have to pollute your global scope. I really hate that, because it's It's also the like the auto completion makes a lot more sense if you have like the module name. So module whatever you imported dot something, you get all the things that are in that module, and you don't accidentally get a bunch of crap in your global scope that you don't know about or you don't know how to find. I mean, you can find it, I guess, but it's also like you include one thing and it could like put a whole bunch of crap in your scope. And then it's just a mess. To be honest. I'm glad that I don't have to live with that. But Twitch is on. Twitch, his or her own. Or they, or whatever. Okay, so... What is going on? Why do we get two different things? I am very confused. Why do we have two things here? And why is this the only one that says init inner? I am confused. Here's like the list. So that's the closure thing. This... So how it works is when the RC logs, it logs its pointer, and so it you can kind of use this as an ID. And you can see this doesn't show any more events. This one does, and this one seems to be the actual like P binding value here, but this one is what's getting. I just don't know where this is coming from. Wait, is it a string? No, the string is here. This is the string here. Also, this also shows a different ID. Or a different thing. Why is it different? Oh, I know why it's different. I know, man, I'm stupid. Okay. Okay, I know it's... I know. The reason why it's different is because when we do this, it's logging. Remember, it's logging its address. What is its address here? There. We don't have the address yet. We probably should put the address in here instead. We should actually, yeah, we should actually do like self rct, so we have the address, and then we just say we populate here. So we populate self is equal to that, and now we can load properly here and return self. Actually, we don't need to return anything. Okay, yeah, that makes way more sense. Okay, now we just need to check. We need to modify this a little bit. So you will have the pointer there. Actually, this will be our pointer, yeah, like this. And that's it. Okay, so now we should get the same pointer. Then you have to use macros. Well, when or what or how or. And that's also one thing that I wish that I like about Zig, that I can use comp time instead of macros, or yeah, instead of the preprocessor stuff. I don't mean to bash on C too much, but I'm just saying. For me personally, okay, I'm just checking phone here. Okay, let's see what if we can work this out here. So now this says the same address, so now it makes more sense. Okay, so we create this binding, we have this there, and then we also release it. Good, but we still have a leak. So we are releasing it, but we have a leak. So at some point, this does not get deinitialized. The inner, the binding value. Yeah, the binding value itself does not get deinitialized there. Right. And we are deinitializing something somewhere. We should probably include the deinitialize options as well, like if we're gonna deinitialize this child. Also, I should probably like have it on a separate line, because it gets a little bit hard to read sometimes. Like this should maybe be in its own line, and then we like indent it a little bit maybe. Maybe we can even build like an indentation writer. Every line gets... No, that's too much work. That's way too much work. Same thing here. We'll just do new line. There we go. A little bit easier to read, I think. Maybe. All right, let's include the options as well. RC. Now, is this log using... RC log. No, it's not. It's its own thing. So I think I want to have a different color there. Let's have like a prefix ref color. And let's make it like orange or something. So we can differentiate a little bit. Wait, I think something else is already orange. This looks orange, but it's actually yellow, I think. This is orange, the command runner. I mean, fine, we can see the difference. So this is now the ref. There we go. Yeah, it's a little bit different. This is the ref, this is the yellow. Apparently this is orange and this is yellow. I'm not sure why you're not seeing it. Okay, so when we deinitialize, we also have like options like if we're deinitializing the child or not. So I'm gonna add that as well here. Now this is the yellow apparently, so it will be over here. Actually, I'll just go to the deinitialize thing. Wait, where is that? Here. So we're logging the function name. Let's add let's do like this. Deinit child is true or false. True. I mean, okay, I guess it wouldn't go into deinit child if it wasn't true. But whatever. You get leaked. You are stored in here. We get a bunch, we get one ref extra here. So we have two refs. We release one ref. We release two refs. Now it gets deinitialized. I should really remove this debug log. Why do I have this? This should just be self-log. Okay. Anyway. So it is release or deinitializing the child. It tries to anyway. Let's do if we have this, we will log a bunch of functions. Wait, do we have the function name? Ah, 1 second. have to go now. I just wanna see if I can solve this here. Let's see. This leaked, which is this one, which is released here and here. But init true with allocator. Okay, it's a special deinitialization function. So let's look at this function here. So it's the binding value, right? So let's go to scope, binding value. No, wait, I thought it was in here. Ah, okay, here we go. I think it's this one, perhaps. So what is being leaked? Pointer to the value itself, I think. So we should free this. I think. Yeah, okay. Alligator destroy self. Wait. Oh. Let's just remove this file. All right. Oh, still issues. Okay. Invalid free. Okay. I think I know why. So we have the binding. The binding has binding value, but the constant is not freeable, so to speak. So I want to create. Do we want to create a ref here actually? Well, let's make this into a thing there. Oh, here was the binding value. Okay. So the binding value is a thing there. And right, now let's create the constant here. Try allocator create binding value and constant is this, and then you are oops constant. All right, cool. C okay. Okay, solve the issue. Boom. Okay. Here you can see what's happening here. Runic. No. God damn it. Yeah. So we got a mutable variable p, which we assign this is p. We have a function that will echo hello p, and whatever is in p, and then reassigns p something else now. So that's just the function declaration, and then we have echo p before hello. So this would be the first thing that gets echoed, because we don't echo anything before. And there we can see this is p. We call hello. Hello will echo out p. This is p again. And then we echo p after hello, and we see p after hello. P is something else now. So it works. No leaks. Oh man, that was a lot of stuff. Wow. Okay, it finally works. I want to try out modules as well. So let's create like module rn, and we'll have like a do we have member access actually on modules right now? I'm not sure if we have. Module function echo hello from module. We can also call it directly here to see that it like you can call the function directly in the module. And then we'll do like module equals import module dot rn. Hello, Rule by Fear, welcome. It is a language, a bash-like scripting language. So when we import this, we actually bind it to this variable. Now the output of this won't, because we're binding to a variable, it won't actually output to the outer scope. So it will be stuck in the module variable. But we could echo the result here, which hopefully works. No, it doesn't. Of course it doesn't. Okay, but yeah, let's see. Script execution error, unsupported command type. What? And then we got leaks, of course. Unsupported command type. Yeah, it's the language. It's called Runic, and the AI decided that RN is a good extension, which works, I guess. I don't know. I haven't checked if RN's used for anything else actually. I mean, it's easy to change anyway. So right now, at least, before it maybe get used. Well, I don't think it will, but. Also, do you not need parentheses for function calls? No. And that is something that is very important here. It's like it's consistent. It's consistency. So it's like a bash-like scripting language. So it's like calling. It's like calling an executable. You could say it's like executing an executable almost. Like functions are kind of like their own like little executables that you define. So that's kind of the idea. But then any arguments, you could define arguments in the parentheses here, and then you could like, you know, provide the arguments like this. So that's how that is worked. Now we don't have arguments right now in the language. It doesn't work. But when arguments will be, it will be something like this when it's implemented. And then you can also use it to like pipe into other, you know, use it just like a, you know, bash pipeline stuff here. Just, I mean, I think in bash you could basically do the same thing. So, okay, why do we get this? Unsupported command type. Oh, is it the scope? No, command type. Why do we get that? Oh, sorry, this is the wrong thing. Scope. This just deinitializes everything. We're evaluating module. The pipeline? Oh, I see, I see. It doesn't know how to deal with this. Right. Yeah, because this is not really... Yeah, okay. So I haven't... You can't do this. Okay. It makes sense. We still get leaks, but... Let's see if it actually succeeded. We get a whole bunch of leaks. Okay, invalid ref. Okay, there's some issues with the import. But I'm not going to solve it right now. Haven't used bash at all. Yeah. By the way, when you call a module, like, can you access the inner scope and feed it input or read its output? Yeah, that's the thing. Well, it doesn't really work right now, but the idea is that you would be able to, you know, you would be able to assign this to this variable, and then whatever has been outputted here would be included in kind of the result here. But we don't have that right now. Right now we only have like this scope, so you could potentially access like module function, for example, and call that. So that's the idea there. But I've been refactoring a little bit on how the execution context is working. So there's some issues with the import right now. But yeah. So just like in, because I tested a little bit how Python works actually, because Python also, you know, you import a module, but in Python it's kind of the same as in Bash, where you can have code straight up in the file that gets executed once it's like parsed or read. So basically, when you import a function or when you import a module in Python, it's gonna, like, all the prints and stuff is gonna get executed. So I kind of have the same thing here, where you import a module, it will execute everything inside, but you're also going to be able to access the declarations and stuff in there, like this. And yeah, there's a whole bunch. There's a whole bunch to go through when it comes to how it works. I should work on having like a consistent, because the idea is that it would be very consistent. Like basically any kind of like expression you have can potentially output to the thing, unless it's like a literal like this. So this wouldn't output anything to the standard out, but this one would. So when you call a function, you would potentially always get some kind of output from it. So so when you call the function, you could get like prints. However, there's a convention now where if you assign it to some kind of variable, then the output is actually not, it's not outputted to the normal standard out. It's going to be stored in this variable instead. So yeah, that's the idea. And then you could use this to this should work, by the way. So if we do well, let's keep that, I guess. If we call, let's just do this, because we don't print anything in here. So the only thing we should see is the result of calling hello. Actually, let me do this first, because now you should not see any output. Yeah, so we don't have any output, but as soon as we print results, we get the output there. And then you can also, like, because you call a function or an executable, it's kind of the same thing here. You actually don't get more stuff. You can it's kind of implied that if you only put result, you get standard out. So this should be the exact same thing. But then you can also get standard error, which is empty in this case. And then you know other stuff that's, you know, on like exit code, except exit code doesn't work right now. But yeah, that's kind of the idea. So every time you capture the output, it goes into whatever you're capturing into. But if you just call it without capturing it, it will be forwarded to the outer scope. What other features does the language support so far? So we have if statements. If true, you know, this is true. We can also do like if, you know, whatever, 2 is less than 3. And we have like else, this is false. That should work, hopefully. Unless, yeah, okay, that works, cool. So, because I've been refactoring a little bit, so everything is kind of messy right now, but we have if statements, we have for loops. You can do this, and we have a zig-like syntax, so this would like capture the element of this range, and it should print 0 to 9. Yeah. So already, we have basic constructs. I just want to get modules working, and I want to also extend the functions, because right now you can't have parameters, and the standard in is nowhere to be found. And also I just implemented streaming output as well, so we can do like tail f server.log, for example, and it will oh shit. It will work now with streaming as well, so that's really nice. So when I have to, oh yeah, also there's a bug in, like, you can have like pipelines like this. Let's say you have this, and then you like, I don't know, echo, no, I don't know, cat, you know, pipe it into anything you want. So this doesn't work now. We have like, I need to have like the multi-stage pipeline work with streaming. Right now it doesn't work, so I have to fix that. But what data types? Well, oh yeah, we also have arrays. So you can define any kind of array like this. So, and you can have like any kind of data type in here. And then you can loop through it with this. And we can do that. And we can get a leak. Of course, we get a leak, but whatever. You can see here that it works. I have to fix some leaks. Yes, Roland Dev, basically. But you can also do this. So you can have array, and then you can provide another range here, which doesn't have an end, and then you can actually get the index out. So this is exactly how zig works. Now we will get the leak here, but I will just show you that you can like get the index very easily if you have an array and you want both the array and the index. You can do this to get them both there. Does it also support hash maps or dictionaries? Not yet. I will get to some more basic stuff, but yeah, I need to like patch up the stuff and make basic things work. We'll see how far we'll get with this language here, but it's very fun to do, and it's nice that it actually works as well. Well, I have to fix up some stuff, but yeah, I have to go now, but yeah, it was nice. Thank you very much for watching here, and hope I catch you later. Have a nice day and see ya.